Hello and welcome to our course Angular 2 Deep Dive. My name is Matt and I will be guiding you through this discovery of the great new framework Angular 2. Angular 2 is vastly different from Angular 1 and aims to fix the issues of its popular predecessor. To achieve this, Angular 2 developers learn from problems encountered with Angular 1, but also try to leverage good features from other frameworks like React.js and Knockout.js. They also integrate modern third-party technologies such as TypeScript and observables for reactive programming. The course will contain 7 sections. In the first, we will bootstrap our application and discuss the use of TypeScript in our code. In the next section, we will introduce the building blocks of Angular 2 applications, components. We will cover many topics like data binding, creating our own component, and communication between components. We will then move to the business logic side of things with providers and injectables. We'll make AJAX calls with built-in and custom services, and review the new structure of providers as well as learn to test our service. Angular 2 comes with a brand new router, which we will discover in section 4. It will allow us to navigate between pages and to organize routes nicely using child routing. A common tool to modify the way data is displayed is by using pipes, which were formerly known as filters in Angular 1. We'll use built-in pipes, but also create our own and differentiate between pure and impure pipes. No application would be complete without a form, and Angular 2 excels at handling and validating forms, so we will learn how to create them in section 6. Asynchronous programming is a vital part of any application written in JavaScript, and so we will conclude the course with a section about promises and observables, the two weapons of choice to handle asynchronous processes and streams in Angular 2. All the code used throughout the course is available at this Git repository, so feel free to clone it and to create issues there if you face any problem or wish to ask a question. Note that at the time of recording, Angular 2's version is Release Candidate 1, and so with future versions, things might change slightly. The code on the Git repo will be updated when major new versions are released or when breaking changes are introduced. I hope you will enjoy the course and the framework. Let's get started. Hello and welcome to the first section of our course, Angular 2 Deep Dive. In this section, we will get up and running by first installing all the dependencies needed by the project. We will then quickly build the first version of our app and serve it in the browser. The next video will discuss how TypeScript is used in the course over plain JavaScript, and why it is a huge win to use TypeScript for your Angular 2 projects. Let's get started. So here are the steps that we will follow in the first video. First, we'll install dependencies, make sure that everything is running fine. Then we will create the root component, which is the base of the application. And finally, we will tell Angular to bootstrap the app, and it will start rendering. Awesomely, with the help of the live reload gulp task, we will see all the changes we make appear immediately in the browser. So here's a list of things that you will need for the project. Node and NPM. Best is to use Node 4.3.2, which is long-term support. Let's quickly install gulp and bower globally. npm i-g gulp bower. Note that if you're not using the Node Version Manager NVM, you will need to run this previous command with sudo. Okay, then we install all the dependencies locally, bower install, followed by npm install. If you run into trouble with gulp sass, please install sass as described at this link. Once all of this is done, you should be able to just run gulp and see the build process, and then your browser opens with this loader here in the middle. So the project and build processes are in place. Let's move to the actual Angular stuff. Let's first open index.html, and you can see that there is one non-standard tag here, the iTunes browser tag, which, by the way, is the application we will build together throughout the course. This element represents the root of your application. It doesn't matter what tag you use, since we will tell Angular which selector to look for. At the bottom of the index, you can see the system.import, which imports the app/boot module. So let's head to that file. Throughout the course, please ignore the JS and js.map files. We are only interested in the TypeScript files. So let's open app/boot.ts. The file is pretty empty right now, except for an import statement. And that is the first thing you need to familiarize yourself with. The way we import modules in ES6. It's import, then curly braces, the items to import, and a path to the module. When using an absolute path, you'll be looking into node modules. See here, for example, node modules, Angular, platform, browser. By the way, that JS file is totally unreadable, which is where typings will come in handy. That's the .d.ts file here, which tells us what is in the module without the clutter of actually seeing the code. But that's for later. We will talk about the awesomeness of typings in the next video. So back to boot.ts. The other import, which is currently commented out, is a relative import, and that means it will be looking at a file using the path relative to the current file. Let's uncomment this, and you can see straight away that the editor complains because the class iTunes app component does not exist yet. Now the import points to app.component in the same folder, and that is where we will create the iTunes browser component. So let's open that. Here again, it's empty except for the import of component from Angular core. Components are the building blocks of an Angular 2 application. To define a component, we'll use add_component, which is a decorator. And what that does is add metadata to the class we declare below. So here export class iTunes app component, which matches the import inside boot.ts. At the moment, nothing is needed in that class since the add_component decorator will take care of everything. The choice of class name is all yours, by the way. There is no naming magic as there was in Angular 1. The component decorator can add many items to the class. We will discover them as we go along. But two that are required are the selector, which needs to match the HTML tag we chose. And the second required property is what markup to display, which can be specified straight here using template. Or, if the markup is more complex, we can point to a HTML file using template URL. So here we're going to point to app/app.html, in which we've already added some markup. Okay, so we have a component, but nothing is showing because we haven't yet told Angular 2 that we even have an app. So let's head back to boot.ts and do that. You can see that the editor's error is gone since we now have a class called iTunes app component in the correct module. All we need now is to use bootstrap with the root component class, iTunes app component, followed by the list of dependency injection items, right now an empty array. And here we have our first app in the browser, which displays the markup found in app.html. So this is actually all you need to get an Angular 2 app started. But this is a deep dive course, so throughout the videos I will try and cover a few extra topics and cases. To clearly separate the fundamentals from the extras, I'll just show a slide like this one. You can safely skip the extras if you just want to get ahead faster, but I think you'll find them useful in the longer run. Now, code-wise, you've been provided with a bundle which covers the fundamental things we learned. That's s1v2_end for this current video. But you will also find a s1v2_extras code bundle, in which you will find the extra topics. So, 4 things we will look at. First, you can very well have other markup in the index. Just because most tutorials have only the root component in that file, doesn't mean you're restricted to that. For example, I could extract this footer and have it in index.html. It's just that it won't be part of the app, so we can't control it. This means that although Angular 2 is great for building single-page applications, you can also decide to use it for just small areas of a site, let's say an image carousel or a chat box. In the same vein, we are not limited to a single application per page. So in index, I can add another tag, say inspiring quote, and bootstrap an app for that. I'm just pasting things quickly here, and the quote appears as expected. The limitation being that the two apps cannot communicate via Angular 2. One last thing about the tag and the selector, you don't actually have to use a custom HTML tag. You could just as well transform this into a div with class equals inspiring quote, and in the actual component, the selector here follows CSS rules, so you can just change this to .inspiring quote, and it still works. Note, however, that only the first match will become an app. If we duplicate this tag, add A, B, and C in each one, you see one quote and then B and C in the other two, which were not considered by the selector. Alright, one more extra. About the bootstrap method itself, it actually returns a promise, which resolves when the app is successfully bootstrapped and rejects when there's an error. So let's add a .then on the two bootstraps, and we'll log a message on success, and in the reject callback, we will console.error what happened, what error was passed. And here we go, two console logs in the browser console. How do we check the error case? Well, let's just change the selector of this quick dirty app to inspiring phrase. And this time we get one log for iTunes and one error message stating that the selector doesn't match. Also note the Angular 2 built-in huge error output there. Okay, so in this video we put our project onto its tracks and we created the root component of the application and we told Angular 2 to start it using the bootstrap method. Before moving on to the next major topic, which is bindings, we will discuss our decision to use TypeScript over plain JavaScript in the next video, and why you really should do the same. In the previous video, we bootstrapped our application and got it to display in the browser. You notice that we are using TypeScript, so let's talk about why there is no question that it is the right choice. We'll start with a quick introduction of TypeScript, not the features, but the background of it. Then I'll give some reasons why Angular 2 and TypeScript are a good match. And finally, I'll introduce some of the actual features of TypeScript, which will make your coding life brighter. So what is TypeScript? TypeScript, a Microsoft product, is a typed superset of JavaScript that compiles to plain JavaScript. Few important keywords here. First, it compiles to plain JavaScript. This means that, in the end, your code is JavaScript. Now, the compilation within our project is handled by a gulp task. You can have a look at tasks/typescript.js for more information. But more important is that TypeScript is a superset of JS, meaning that you can take any JavaScript file, change its extension to .ts, and you have TypeScript. It's kind of like moving from CSS to Sass. It's very straightforward. I think those 2 points are well summarized by this statement on the site. TypeScript starts with JavaScript and ends with JavaScript. So why go TypeScript for Angular 2 project? TypeScript is gaining a lot of traction. Here's the Google trend for TypeScript versus CoffeeScript and a few other alternatives. And particularly in the last 12 months, you can see a strong interest for TypeScript, while CoffeeScript and Dart are dying off. Also, quite importantly, TypeScript is the way that Angular 2 wants you to go. It's well known that the Angular 2 and TypeScript teams have been working together. You can see posts from Microsoft about their fruitful collaboration. Even the Quick Start guide from Angular 2 takes you to its TypeScript version, and even if you were to switch to the JS version, they kind of encourage you to go back to TypeScript. Now, as I said, I'm totally biased because I love TypeScript, but I'm really confident that you will too. Now, TypeScript does need some getting used to, so let's see how to avoid the few annoyances that are likely to happen when you start coding with it. First, you need to get used to declaring properties on classes. You won't be allowed to just set any property onto the this object, not without declaring it on the class first. For example, if we wanted to add first name and last name on our component, TS wouldn't be happy unless we declare those properties on the class. We can either set them as public or private. If we don't specify, it means public. Does it sound annoying rather than helpful? At first maybe. But declaring the properties of a class will allow your editor to do very helpful autocompletion and to highlight problems when you're trying to access properties that don't exist or are private. It also helps you structure your class better. By the way, if all we're doing in the constructor is setting this.firstname equals to a value, this.lastname equals to another, we can actually initialize the variable straight in the class declaration instead. In a similar way, TypeScript enforces types. It looks as though we haven't made use of that yet. But actually we did, because TypeScript infers type where it can. So if I were to try and change this.lastname to be a number, the compiler will not let me do that, because from the initialization here, it inferred that last is a string, not a number. So how could I manually specify the type? Simply add a colon after the variable name and a type, which is string. Now that doesn't solve our problem with the number though. But since version 1.4, TypeScript allows for union types, so we can do string pipe number, meaning that either a string or a number is allowed. Again, This might seem like a restriction, but it's actually great because your editor will point out issues as well as help you use the right type which the class or the method is okay to work with. In any case, if you wanted to allow any type of variable, you could simply use the any type, and anything goes, as you can see. As I mentioned, a really big part of what we gain from using TypeScript lies within your editor. I've shown just now how we were told off immediately when trying to assign a number to a string type variable. In a more constructive way, editors will do great autocompletion with TypeScript. Let's define a fan method here, and we will return this dot, and there you see that we get information about the available variables, including their expected type. My current editor, Atom, would also be smart enough not to show you variables that are private if you were not within the instance itself. It's also smart enough to autocomplete while within the ES6 template literals using backticks. The same goes for importing. Let's go into the curly brackets here, and because the module is already specified, the coding environment knows what we can import, and if we type EL, we'll see the corresponding options within that module. You'll find that this is really helpful. Now let's indeed import element ref, because that leads me to the next point, Angular 2 integration. We will not talk about the new dependency injection mechanism until section 3, but if you know a bit about Angular 1, you know that you can request for services inside controllers, or here in Angular 2, inside components constructor methods. And how do we specify what class or service we need? We write elref, element ref, meaning that just by specifying the type inside the arguments list, Angular will know that it needs to instantiate a new element ref object and pass it here as elref. Of course, elref dot shows us all we can do with that object. And even better yet, assuming that we want to reuse the element reference in the fan method, we can specify private or public within the arguments here, and the instance gets set onto the this object, meaning in fan we can include this.elref.native element. So to summarize, TypeScript can only bring improvements to your code, because it only attempts to help you write better code. A huge part of its strength lies in the integration with the editor, so make sure to use one of these editors with the corresponding plugins. Now with this you should be able to continue building with Angular 2 and not be too distracted by the novelty of TypeScript. But let's now look at a couple of extra topics. First of all, remember that TypeScript starts and ends with JavaScript, which means that even if TypeScript isn't happy to compile, it will still output valid JavaScript. And things like private variables and enforcing types, which are not part of JavaScript, won't be strictly implemented. Here, let me create a new instance of the component class, change the last name to be private, and window.alert the last name of this instance. Despite all the complaints by TypeScript, class signature not matching, last name being a private property, when we look in the browser, we still get the alert. A more constructive example of that is interfaces, which you should use extensively. Let's recode this component, and I want to set a person property on the class, which I have to guarantee has a first name and a last name, like this. Alright, here the any type would work fine, but then within the fan method, I get autocomplete to this.person, but not on the person, nothing comes up. Trust me, once you get used to TypeScript, you'll feel quite unhappy when no autocomplete happens. So how can we improve that? We're going to declare an interface called person. We know that we need first name and last name for fan to work, but at the same time, we don't want to go all the way to a class that's a bit too strict. So let's write interface and then declare the required property, and while we're at it, let's introduce an optional property age using the question mark on the property name. So now all I need is to tell the class that it's expecting a person, and within the constructor, make sure to create the corresponding object. Just a simple JavaScript object with at least the first name and last name properties, and optionally the age. The editor will let you know when you're good to go. And here we have the autocompletion back, even on the person property. Now that's not quite duck typing yet, since we have to match the interface signature exactly. So what if we wanted to add extra properties on the person here? We just need to tell TypeScript to consider this as a person using the angle brackets. And as long as it meets the requirements of having a first name and a last name, TypeScript is fine with it. This is actually brilliant for refactoring. What if I suddenly decided to use an object that has first and last instead of first name and last name? Then TypeScript will point out that there are issues here. So in this video, we learned about the basics of TypeScript, and I hope that you can see that despite the first few features that require some getting used to, TypeScript is really there for only one purpose: to make your code better. In this section, we got our project set up and introduced TypeScript. So we're now ready to move into one of Angular 2's main features, components. Let's cover that in the next section. Hello and welcome to the second section of the course, in which we will talk at length about the basic building blocks of Angular 2, components. We will start by adding data onto the root component and use one-way data binding to affect the view accordingly. We will then, in reverse, learn how interactions on the view can be transferred to the component side. At first we will be doing this with built-in bindings, but then we will create our own component and add inputs and outputs to it. In the last video of the section, we'll talk about directives in Angular 2, which are components without a view, and we'll build one as well. In this first video, we will talk about using data from the component to be displayed inside the view. We'll make use of various methods of displaying data in DOM nodes, whether plain text, HTML, or using properties such as the source of an image. Then we'll show how to use logic to display or hide elements, as well as change their styling and CSS classes specifically. Let's have a quick look at our current setup. You can see a file called data.ts, and within you'll see that I've declared an interface to represent each track that we receive from the iTunes API. Below, I've copied some results from an actual API call, searching for the term Jack Johnson. The entries match the interface. So let's open app.component, and the first thing in order to use the data from this component in the view is that we need the data to be set on the this object. Now let's say we want to display the search term that we queried for. We'll add this.searchTerm within the constructor equals Jack Johnson. Of course, because of TypeScript, we need to declare that property on the component class as well. Let's now switch to app.html. We can bind to the search term property by using the double curly braces notation, same as in Angular 1, and the search term appears in the browser. Another way of displaying text is by binding to the element's inner text property. To do this, we'll write inner text, that's the attribute name, enclosed in square brackets, and equals to the property on the component object, which is search term. The result is the same as with the double curly braces, but this is important because, as we will see shortly, you can do this with any attribute of the element. So to make things more interesting, let's display a row for each track we receive from the search. For this, we'll use a ng4 directive as follows: asterisk ng4 equals hash track of tracks. Although it looks a bit odd at first, the syntax is actually quite straightforward. We want to repeat this div for every track item of the tracks list that was declared on the component. The two symbols, the asterisk and hash, are just things that we'll need to get used to. The hash here in particular is Angular's way of creating a local template variable which will be available only within this DOM element. As for the asterisk, just remember to use it on ng4 and ngIf template directives. I'm sure you'll get used to it very quickly. Actually, it really is only synthetic sugar to avoid the verbose version, which looks like this. So now, because we wrote hash track here, means that we can access all the properties of each track item within this div. As we did just now, we can use a property binding to inner text to display the song title. But we can also bind to other properties. For example, we could bind a paragraph's inner HTML this time to an expression. And in that expression, let's add some HTML tags plus the name of the album. We can also very easily bind to attributes that don't directly display text. For example here, let's add a div with an image, and we bind its source attribute to the artwork of the track using the same square bracket notation. As you can see, unlike in Angular 1, there are no more ng-everything. We can bind straight to the properties or attributes of the element. How about showing and hiding elements? Well, we can easily bind to hidden using the same square brackets again on the element. For example, hidden equals
and we'll hide every row where the tracks album is not in between dreams. So that basically replaces ng-show and ng-hide from Angular 1. Now here comes an interesting binding on styles and classes. Of course you can bind to style, as with all the other element properties, but often you'll want to affect only a particular style. Angular 2 makes that very easy to do by binding to style dot and the name of the style you wish to change. Let's say font weight. And let's make that bold if collection name is in between dreams and normal otherwise. In a similar way, often you'll want to toggle a certain class on an element, and you can do that by binding to class dot and the name of the class. Now, if the expression here evaluates to true, then the class will be added and it will be removed otherwise. So here we have seen how we can easily use one-way data binding to achieve many very common tasks: displaying data, showing and hiding elements, and toggling specific styles and classes. Note, by the way, that this is one-way binding, not one-time binding, which means that Angular 2 is still watching for changes. If I were to set a timeout here and after a few seconds I'm going to change the search term, you will see that it changes on the view. Now for the extra topics this time around, I want to look into the ng-for directive a little closer. When using an ng-for repeater, we declared a local variable, track, which represents each item. Well, there are a few more variables made available from within the ng-for microsyntax statement. We have index, which we can assign to a local variable, let's say #i, and now I within the template will represent the index of each row, meaning we can have a div here and we display i+1 to number the rows. If you're familiar with Angular 1, you probably remember $index, but watch out that the index is not made magically available to you. You need to declare this local variable #i straight on the same component as the ng-for. Now, why is that better? Because let's say you have another ng-for within, like the example I'm showing now, then you can decide what the name of the index variable is yourself. You don't need to worry about $index clashing. So for example, we can display I, the index of the outer ng-for, and then k, which is the index of the inner ng-for. And you can see the two index values are displayed correctly. Now, other variables that can be assigned locally from an ng-for microsyntax are odd and even, and last. So let's have #isEven equals to even, and then let's have isLast equal to last, which is also a boolean, and that boolean will be true if we are on the last item. Now let me quickly use isEven to decide the background color of rows using a binding to style.backgroundColor. And how about we display a link to go back to the top of the page on the last element? Well, we've already used binding to hidden earlier in this video, so let's introduce something new. How about we use *ngIf, which is another template directive, and so don't forget the asterisk, and then we'll do if isLast, then this DOM element will be created and it will be destroyed otherwise. Let's have a look at this in the browser. You can see the color changes on even rows, and on the last item we see our anchor element. It's interesting to actually inspect this row and compare it to the previous one. You can see that the link element really doesn't exist at all on the previous row because we are using ngIf. We're not hiding the component, we're actually creating or destroying it. So in this video we learned how to bind data from a component to any attribute of an element using the square brackets notation. And we use this to display text in HTML, show an image, display or hide a node, and change the styles and classes of an element. We also had a look at a couple of directives, the repeater, ng-for, and ngIf, which decides whether an element exists or not. Now, this was binding from component to view. In the next video, we will see the other binding direction from the user interactions to the logic of the component. In the previous video, we used data from the component to be displayed in the view. This time, we will be responding to view changes with logic in the component. We will start by introducing the round brackets binding on element events, and we'll pass on the event data within the callback. Then we will create a two-way data binding on an input using ngModel. And finally, we'll bind to specific events, similar to what we did with class and styles in the previous video. Binding to events is simply the other direction of data binding. Where we previously bound from the component to the view using the square brackets, we are now going to bind from the view to the component using round brackets. For example, here in the search box, we're going to bind to the change event of the input by writing change inside round brackets. And that will be equal to, and here we'll put an expression which will be evaluated when the change event is triggered. Search term changed, and then brackets, because we're going to call a function. Note that even though we are calling a function here, any template expression would work. For example, we could say that on focus, so round bracket focus, we set is searching to true, and then on blur, we set it back to false. This results in the search for label getting bolded because we have bound to the font weight style here on the label. Let's add one more binding on the button here. On click, we're going to call execute search. Now we need to code those methods on the component. So search term changed, I'm going to just log a message. And let's do the same with execute search. Now you can see that on click and on change, which by the way triggers when we exit the input, when that happens, a message is logged in the console. Now we can of course pass arguments to these methods. We could pass the search term to click, for example. And there's one special keyword, which is $event, which will contain the event data. Now in this particular case, when we go back to the component side, in the method here, it means that we will receive the search term, so term, which is a string, and we will receive the event, which in this case is a mouse event. I'm just going to log a message with that term again, and for the event, let's use a property of the event. Let's check whether the shift key is pressed, and we'll set the search term to an empty string if the shift key is pressed. Let's have a look at it in the browser, and so if you click, you see the search term value, and then if you were to shift click, you can see that the search term is changed to an empty string, and so it disappears here from the view. And this is how you bind from the view to the model using events bindings. Now clearly what we want to do is actually to clear the input, not so much the value here. And when we click to execute the search, we want to read the value from the input, not what we hard-coded, not Jack Johnson. So what we need this time is actually two-way data binding. From the view, when we type in input, we want the value in the component to change. And from the model, if we change the value, we expect it to take effect on the view, following the MVVM pattern. And in Angular 2, this can easily be achieved by using the ngModel directive. And to bind that two ways, we need to use square brackets as well as round brackets. What we'll bind to in this case is the search term value on the model. As you can see in the browser, the moment we type something in the input, the model value changes, and this gets reflected on the view here in the tracks by box. Now if we click on the search while holding the shift key, in the model we clear the search term, and that again reflects on the view. So we have achieved two-way data binding. Now before we move on to the extras, let's add one last touch. Let's execute the search if the user types the enter key as well. So we would be binding to key up using the round brackets, and we could of course pass the $event parameter, which would allow us to check which key has been pressed, and we could check whether it's the enter key. But Angular 2 provides something even better, similar to what we did with one-way binding for styles and classes. We can actually bind to keyup.enter, which is what Angular 2 calls a pseudo event. And there, in the browser console, you can see that execute search will be called only when we press the enter key. So here we learned how to bind to events as well as to achieve two-way data binding. For the extra, I just want to talk about referencing the element locally. Remember how in ngFor we used #track to create a local variable that refers to each track? we also saw that we could assign hash I to the index. So the hash is the notation that means create a local template variable. Now there's one that we can define on any element, and that is a reference to the element itself. To achieve that, we can simply add hash, let's say input element, on the input here, for example. And now input element is a reference to the DOM element itself. And so the search term passed in the execute search method could actually be obtained from input element dot value. That could be useful if, let's say, we had not implemented two-way data binding. I'm going to remove the ng model for now. Note that the input element reference is also available elsewhere within the same component. So we could use the input element dot value within the button here, and we'll still get the correct search term. Now, one of the reasons for this is that Angular tries to support native browser features. Where possible, it's not trying to replace something that already works. So let's take the audio element, for example. I'm going to create a preview for each track using an audio element and within a source element. And for that source element, I'm going to bind the src attribute to preview URL, which is available on the tracks. Now on the audio element itself, I'm going to add hash audio so that we can access the element directly. Then I'm going to add two buttons, and on click, we'll have audio.play and audio.pause. Audio here refers to the audio element directly because of the hash template variable. So you see that we are not forced to create an Angular component for every single thing if it is not needed. Wherever we can use native integrations. So in this video, we learned about binding from the view to the component using round brackets on events, as well as two-way data binding using ng model. And we covered local element references. So far, we've stuck to using that one big component, our root iTunes browser. We will remedy to that in the next video by creating our own component. In the previous two videos, we learned about data binding, both from the model to the view and from the view to the model. But we did all this within our one main root component. In this video, we'll extract one part of the app into its own reusable component. We will start by creating the component class with its own template, and next we will make sure to have that new component available in the root component. Finally, we'll talk about styling within the new component. So let's open the app.html file, and here you can see that the search bar is made of a label, an input, and a button. But conceptually, this is one component, a search bar. Now Angular 2 is all about building reusable blocks or components, and that's what we're going to do here. So let's create a new folder called search. That's because in Angular 2, we like to organize things by feature. Now, within, I'm going to create a new file called searchbar.component.ts. Similar to the root component, we're going to import component from Angular core and use that decorator here and export a class called searchBarComponent. Nothing is needed in the class right now, but within the decorator, first we need a selector. And for this, I will choose searchbar. Switching to the app.html file, let's cut the label, input, and button, and we'll replace it with a searchbar tag, which matches the selector we just picked on the component. Back to the component file, let's paste that HTML back into the template property of the decorator. So we have the selector in place, and you'd expect those three elements to show up on the page. But as you can see, they are not. This is because the root component isn't aware of the new component we created. So we need to head back to app.component and add the directives property to the decorator. And that will be an array which contains the component or directive classes that this component needs to be aware of, and it will try to match their selector. Now the class in our case is searchBarComponent, and we need to import that class here at the top. Once we add that class to the directives array, we can see the search bar appear back in the browser. Now when we click on the search button, however, in the console we get a big error which can be summarized to execute search is not a function. This is because we did not define that method on the search bar component. It is on the root component. And in Angular 2, there is no inheritance like what we had with scopes in Angular 1. So we need to move the execute search from the app component to the search bar component. We need to declare the public property search term on that component. And let me revert to using ngModel instead of the reference to the input element. Of course, this means that the search term is only accessible within this component, whereas we will need it later to actually call the API. But we will look into that communication between components using inputs and outputs in the next video. So for now, we have a nicely encapsulated, small, reusable component, which is what you should aim for in Angular 2. Let's encapsulate one more thing in our component, styles. As much as we love CSS for a lot of cases, I'm sure we have all experienced having to add an ID on an element or something similar so that a particular style affects only one of our components. Well, we don't need to do that anymore. In the component decorator, we can actually declare a styles array and populate it with strings of styles. For example, we can decide to have a background on the input on hover. And that only applies to your component. If I added another input in the app component, you can see that it doesn't become gray on hover. So this is how we can apply specific styles to our component. It might feel a bit odd at first. Why aren't we using just CSS? Well, of course we still are, just more specific. Why? Because of clarity. It is much better to know exactly which styles will be applied to your new component rather than try it, wait and see what it looks like in the browser, and just inspect to see which CSS rules will turn out to apply to your component. Now, that doesn't mean we are putting away dry concepts, not at all. Let's have a look at the component we just created. The styles property is an array for a good reason, because it will allow us to import styles and add them here. So how does that work? Well, let's create a styles folder. And I'm going to create a forms.ts file. And let's export a constant called hover input. And here that's just going to be a string. And we're going to paste what we had in the component. Now by doing this, we declare a style which can be reused anywhere without having to concern ourselves with selectors. So now in the component file, we can import from .styles and forms. And we use that to import hover input. So now we add this into the styles array. And of course, the idea here is that we could add other styles from other files. So we're working with styles, but in a way with which we are much more comfortable. It's declarative. I can look at my component and know straight away what styles are going to apply to it. It's also reusable, easy to change, and well structured since we can use different files. Also, we know that it will not affect other components randomly. Now you might feel a bit odd at first since we are so used to CSS, but very quickly you'll see the benefits of this approach. Right, so now we know how to create a component, make it available in the parent component, and even how to style it. Now for the extras, I just want to look at how it works that those styles only apply to the component. This is actually achieved by using the shadow DOM, which is a feature of web components, whose goal is to separate presentation from content. If you're interested in how the shadow DOM works, I suggest you read this excellent article by Dominic Cooney. To summarize it, what it does is that it encapsulates templates and styles to avoid them bleeding out to other components. Now, what about in Angular 2? Well, Angular 2 gives us 3 choices on how to use the shadow DOM. To switch between them, we need to import view encapsulation from Angular core. And in the component decorator, we need to add encapsulation and then colon view encapsulation dot. And here, of course, the editor shows us the 3 choices: none, emulated, and native. Let's start with setting the value to none. I'm going to switch to the browser and inspect the DOM. And as you can see here in the head, our styles have been added by Angular. Of course, since we said no encapsulation, these styles will now apply to the entire page, thus having potentially annoying side effects. Now what if we switch to emulated, which by the way is the default? Well, we still see the style tag, but it is set to only apply to an input with a strange looking attribute. Well, that was actually added by Angular in order to force encapsulation. If you look at all the elements within the search bar component, you can see that all of them have that attribute set to them. So because the attribute is quite unique, it is extremely unlikely to conflict with styles outside of this component. And that's how Angular 2 emulates the shadow DOM. Now this protects the outside DOM. However, the component itself is still affected by external styles, which is not exactly what the shadow DOM tries to achieve. So let's change our encapsulation value to native this time. Look at the result, and you can see the shadow root element, and within that element only, you can see the styles. So there's no need for any weird attribute anymore. Now the styles on this component don't affect external elements, and external styles also don't affect the component. Now if you're thinking that this doesn't look as nice, you can refer to the S3 Extras bundle to see the full version, where I have basically extracted the forms and the button styles and made them available so we can reuse them in the components as we see fit. So in this video, we learn how to create our own component and how to style it. Now clearly, we need that component to be able to communicate with its parent so we can execute searches. We will learn how to achieve this in the next video.
In the previous video, we created our own component, and we very quickly saw the need for it to communicate to the outside. Let's learn how to achieve this in this video. We will start by creating another new component to represent each of the tracks. As such, we will need to be able to pass the track model to each instance of the component. We then will learn how to communicate from the search component to the outside by using an output. So let's open app.html, and the template here looks already much cleaner with search bar as its own component. The track div that we repeat isn't overly complex, but still it makes sense to make it into its own component. I've already created a new folder called tracks, as well as a component file, and declared the track component class. And so we'll simply copy the entire markup that represents the row and paste it into the template of the component. Of course, the ng4 doesn't belong in the component, so let's remove that. And let's also take note of the selector for this component, track-row. Now back in app.html, we're going to add a track row element with the same ng4 we had previously. Let's look at what happens in the browser. We need to inspect the elements, and what we see is that a track row element has been created for each result, but we don't see anything on screen. Also, in the console, we can see an error caused by the new component in which we tried to use artwork URL of the track object, but that track doesn't exist within that component. This is where we're going to use an input property, which allows data to flow from the template into the component. For this, we need to import input from Angular core and use it as a decorator in the class addInput. And don't forget the brackets, otherwise the decorator won't take effect. And then the name of the property, let's say track. Now to leverage types, I'm going to import the track interface from the data file and add the type on the track input. Back to app.html, we'll provide each track. I'm changing the variable name so you can see clearly which is which. So we're binding the track object to the track input using the usual square brackets. And the browser shows the correct display again. So this is how you can allow communication from the parent component to its children using input properties. Note, by the way, that the name of the binding does not necessarily have to be the same as the property on the class. Let's say we wanted to make it clearer what this binding represents by changing the binding to track-model. We could then, inside the brackets in the input decorator, put the new name as a string, and the input still works as expected. Whereas within the component, track is still the name of the local property. So that takes care of passing data from the parent to the child.
But remember how in the search bar component, we realized that we also need to be able to communicate from the search to the outside, to the parent. Well, just as we used input just now, we are now going to use an output property. For this, we need to import two things, the output decorator and the event emitter class. In the component class, we can now add @output, and again, don't miss the brackets. And the name of the event we will allow to bind to, let's say execute. That property, we will need to make it equal to a new event emitter. Now, when do we actually want to trigger the event? When we execute the search. So that would be here if the shift key is not pressed. And to actually trigger the output, we do this.execute, that's the name of our emitter, .emit. And what we pass to the function is what will be made available via the $event value. So let's pass the current value of the search term. Alright, the component is ready. So in app.html, we can now bind to the execute event using the usual round brackets, equals, and then the expression. Let's make that run the search, brackets, and we're going to pass the $event special value here. And that will contain the search term that we passed to the emit method of the event emitter. We now need to edit the root component file and declare the run the search method, which will receive one parameter, the search term, which is a string. Let's cheat a bit here and filter out the results according to the search term until we learn how to actually conduct the search using the iTunes API. So this.tracks equals the full results.filter, and then we check whether the title contains the given terms. Note, by the way, that in the same manner as we renamed the binding, the input earlier, we can also rename the event here by putting the new name in the output decorators brackets, say execute search, and modify the template accordingly. Okay, so now we know how to communicate between a parent component and its children, either passing data using an input decorator or from the children triggering events using an output decorator. For the extras, let's implement our own two-way data binding between the search term inside the search bar and straight into a type term property of the root component. We saw in the previous video that you can use ngModel with square and round brackets to achieve two-way data binding on inputs. But if you think about it, we could implement the same using @input decorator for one way, from parent to child, and an output decorator for the other way, from child to parent. So we're going to bind two ways something we'll call term using the round and square brackets, and in this component it'll be bound to typed term. Let me quickly add something to display the value below and a button to clear that value on click. Now on the search bar component, we need to add the corresponding input for term, and for the output, we will have to use an output decorator, but with a specific name, term change, meaning the name of the input and then change. The reason for this is because the square plus round bracket is actually syntactic sugar for term as input and term change as output. Now we make that output equal to a new event emitter, which by the way is a generic, so we can specify that it will emit string here. To keep things simple, let's bind term to the input value using ngModel, and so the bindings will trickle further into the input element. Now the value changes on key up, so let's bind to that event on the input, and we'll call term has changed, which we then code on the component and simply this.termChange.emit, and we'll pass the current term value. Note that due to the generic here, I wouldn't be able to pass an array or anything else than a string. And that's it, we've created our own two-way data binding, as you can see in the browser. Now if you're thinking that we could have tried to use change detection on the model value, that's actually correct. And we will cover that in a future section, but this works well. So in this video, we learned how to bind data from the outside into our component and how to communicate to the parent using event bindings. We also implemented two-way data binding between the components. In the next video, we will learn how to project markup provided by the developer into one of our components. In the previous video, we used input and output, which allowed communication between components. In this video, we'll talk about content projection using ng content. We will start by creating a custom audio player, which can be customized by the developer, and for that we'll use content projection with ng content. We will see how we can specifically project content into various parts of our component. That will lead us to introducing concepts such as element ref, view child, and content child. So if we look at the template of the root component, we've created a search bar and a list of tracks. Each time, the component is empty though, we didn't put any DOM element inside the tags. So let's say we wanted to create a custom audio player to replace this audio element and use it inside our track component. So let's make it cool audio. And to make it really reusable, we don't want to bind to anything on that component. The developers just need to provide the source elements, like this. So let's code that component. Add component, and the template will be a div with an audio element and 2 buttons. Now to include the source elements passed in the template of track row, we will use ng content, which performs content projection. At the place where we want the content to be inserted, that would be inside the audio tag. Don't forget to add the directives array with the cool audio class inside the track row component. And now you can see that the source element is projected into the audio element, and the songs play correctly. We can also get more specific with ng content projection using the select attribute. In this audio here, we only want source elements, so I'll add select equals source, where this right hand side is a CSS selector, meaning all the source elements provided will go in here. We can use any CSS selector. For example, let's give users control over how they want to implement buttons. So we're going to add a second ng content with select equals to dot play button. So that will match elements with the class play button. And let's have a third one with square brackets stop button. So that will match elements that have that attribute. Now in the track row template within the cool audio element, we can add a button with class play button and another one with attribute stop button, and they will be projected into their respective ng content. Note as we inspect the DOM that the ng content elements are not present anymore. They get replaced with their content. So in this way we will be able to compose components with other components, and that's the purpose of content projection. Now how would we implement play and stop on the buttons? First we bind those methods to click, and every component can request a reference to its own element by requesting it in the constructor. This is using dependency injection. We import element ref and then simply ask for it. A convenient feature of TypeScript, we can declare the variable as public or private within the constructor method, and it will be set on the this object. Now when we declare the play and stop methods, they can both call this.el, native element, let's say query selector audio, which means grab the audio element within the cool audio element, and then play for play and pause for the stop method. As you can see, the play and pause button are now working in the browser. You'll notice that I repeated the query selector in both the play and stop methods and did not try to set a class property pointing to that element in the constructor like this. Let me put a debugger here so we can see why. The reason is because as the component is constructed, the element here is empty. Angular 2 has not yet completed the initialization of this component's view. If we wanted to query only once, we would have to use one of Angular 2's lifecycle hooks, namely the ng after view init, which is called once the component view has been rendered. Within that method, we could set this.audio element equals to this.el.nativeElement.querySelectorAudio. Now audio element needs to be defined on the class, and its type will be any. Once we do that, we can substitute the selectors in play and pause with this.audio element. There is, however, a better way to query the DOM than going through the element, and that uses the viewChild decorator, which I'll import now. Remember that we can create a local template variable using hash on any element, and that's what I'll do on the audio element here. In the declaration of the component class, we can now use @viewChild and pass the name of the hash variable to ask Angular 2 to query the DOM and find that element. And this will give us ngAudio element, which is of type elementRef. Now within the viewInit hook, we can change to this.audio element equals this.ngAudio element.native element. Now since we're talking about content projection, what if we wanted to access the source element passed from the track row? Let's give that a hash template variable name, let's say source element. If we were to query using viewChild as we did for the audio, you'd find that the resulting query gives you null, because viewChild looks inside the template here for an element, and source element isn't inside that template. Instead, it is inside the projected content, and so to access that, we have to use a different decorator, contentChild. Let's import it at the top, and it works exactly in the same way. I'll just rename the class property. And now in play, we could console log this.ngSourceElement.NativeElement.getAttribute source, for example. Let's see the result in the browser. The song plays, and we see the log of the value of the src attribute. So we've used viewChild and contentChild to query the DOM and grab element references. But something really neat would be to abstract some of the behavior of that audio element. Let's create a new component that represents that audio. As a selector, I'm simply going to use audio, and since I don't want to do anything template-wise, I'll just project everything using ngContent. It'll be nice to handle play and stop within the component, and here I'll use elementRef, dependency injected into the constructor, and keep a reference to, let's say, native, which will be the native element for the audio node. So now play is this.native.play and stop is this.native.pause. Why not add one more property? We could define a source property using a getter method, and what we'll do is just query the source element within and return the src attribute of the element we find. So you could define any number of other properties or methods that you would want to use for audio elements. It's kind of like enhancing the DOM. Now in the cool audio component, let's add that new directive to the list of directives in the decorator. And then instead of passing a string to viewChild, we will pass the class itself. And now ngAudio element is going to be an audio component instead of elementRef type. We don't need these other class properties anymore, or the local template reference, so I'll remove that. And instead we have direct access to the directive and its extra features, so we can play, stop, and also use the source property we defined earlier in the template. This is really neat, as I said, it's like enhancing an existing DOM element. So in this video we've created a component into which we project content, and we saw how to work with the reference to the container of the component. We also introduced a first lifecycle hook triggered once the view is initialized, and used two decorators, viewChild and contentChild, to query the DOM. In the next video, we'll talk about components without a view, which in Angular 2 are called directives. In the previous video, we used ngContent to allow content projection into our custom component. In this video, we'll talk about components without a view element, which in Angular 2 are called directives. We will first create a preview directive whose job is to play an audio on mouse over. A directive in Angular 2 is simply a component that does not have a template. For bindings, we'll make use of the host property, and we will see how to transform the audio component from the previous video into a directive. So as an example of directive, I want to create something called preview, which I can set as an attribute on any element, and on mouse over on that host element, I want to find any audio element within and have it play. Achieving this is very similar to creating a component. First, let's import the directive decorator. and then we'll write add directive, and we'll provide a selector, which will be square brackets preview. This is a CSS selector, so it means simply that it will match an element that has preview as attribute, as we have set on our div here. And as mentioned, the directive does not need a template. But yet, we want to add events on the element which contains the directive, since we want to react on mouse enter and mouse exit. To achieve this, we'll use the host property of the decorator, and there'll be an object with key values representing the bindings we wish to implement. So we would want to bind to mouse enter, therefore the first key would be round bracket mouse enter, and the value is the same as the expression we would have normally typed in the template, so let's say play. And we can do the same with mouse out. We saw in the previous video that we can access children using viewChild and contentChild. Now, since directives don't have a template, we can't be using viewChild, and so we will have to use contentChild here to grab the audio component. As a result, the implementation of play and stop is very straightforward. Let's simply use this.audioComponent.play and this.audioComponent.stop. Now don't forget to add the preview directive class to the array of directives on the cool audio component. Let's have a look at the result in the browser. The moment we mouse over the player div, the corresponding song starts playing and it stops again as we exit. This directive could be reused anywhere as long as the host contains an audio element. Now looking back at the audio component we created in the previous video, it becomes clear that this should be a directive, since all we do is project the entire content into the template. So let's change that decorator to directive, remove the template, and rename the class to audio directive, and let's just rename this to audio directive everywhere in the preview as well. So this is what a directive is, a component without a view. Now the extra content that I want to show is about using content children, which not only accesses children, but allows to watch for changes of a list of children. It takes a bit of preparation though, and please ignore TypeScript complaints for the next few minutes. So first, instead of binding to the preview URL for the source, I'm going to add an ng4 and use #s of track.sources, which is a property that isn't defined on the interface, hence the TypeScript complaints later. Also, we will display the number of source elements that each row has in a paragraph using a property number of sources, which we'll define on the class, and we'll default that to 1. So in app.component, I'll add a constructor which for each API results sets a source array made of preview URL only. So basically we're back to the same as before, except that we use an ng4 on the array which has a single element inside. Now in order to showcase content children inside a set interval, I'm going to add a source to the first result only every couple of seconds. Value doesn't matter, and now if you looked at the browser and inspect the elements, you'd see that on the first row here, a new source element is added every couple of seconds. Okay, so we are all set up. Now back to the track component, let's import content children as well as the query list class. And let's create a source directive with source as the selector. It's the same concept as the audio directive and nothing else on the class. Now in the cool audio component, let's add a property which is content children of type source directive. Let's call it sources. And type-wise, that's going to be a query list of source directives. This is similar to accessing a single child as we did with content child, except it gives us a watchable list. I've mentioned before about the ng after content init lifecycle hook. So within that method, we can now add this.sources.changes, and that's actually an observable. Think of it for now as an event listener, and we can subscribe to it, and we'll receive the list of items, which is of type query list source directive. Now in this callback here, we simply set this.number of sources to be equal to items.length. A final thing, in the track component itself, we need to add the source directive to the directives array, since that is where the source elements themselves are found. And there you go, in the browser you can see the message changing as the number of sources is being incremented every couple of seconds. This is extremely powerful as opposed to just querying the containing element. We can actually watch for changes in the list of matched directives or components. So in this video we learned how to create a directive, which is simply a component without a view, and how to set event bindings on its host element. This concludes the section on components, and you hopefully by now can feel how powerful Angular 2's building blocks are. In the next section, we will focus more on the business logic side of things by introducing injectables and providers. Hello and welcome to the third section of the course. We previously looked at components. In this section, we will focus on business logic using injectables and providers. We will start by using built-in services to make calls to the iTunes API. Then we'll create our own service using the injectable decorator. We will then introduce providers and look at how Angular builds a tree of providers that follows the component hierarchy. Finally, we'll code and run tests on our services. In this first video, we will make actual calls to an API. For this, we will use Angular's built-in HTTP service. We'll make that service available throughout the app, and we'll learn how to handle the response, whether successful or unsuccessful. So instead of the previously hard-coded results, we want to load data from the iTunes API using an AJAX call. Angular 2 gives us a service for this, the HTTP client, which we can import from Angular HTTP. Services are made available via dependency injection. So in the constructor of our component, we're going to write private HTTP : HTTP. Meaning provide our component with the HTTP client, that's the class here, and set it as this.http. If we save the file and look at the browser though, we get a dependency injection error, which is no provider for HTTP. This is because we haven't told our application how to make the HTTP client available. To do so, let's head to boot.ts, and we're going to import HTTP providers from Angular HTTP. Why not just the HTTP client? Because in order to work, the HTTP client needs a bunch of other services, like the XHR backend and request options. So HTTP providers is just a convenient shortcut for everything we need to make AJAX calls. Now in the bootstrap method, the second argument is a set of custom providers, in which we can add HTTP providers, and now the HTTP client will be available throughout the app. Let's head back to our component, and in the run the search method, we can now make a call to the API using this.http.get, and then the URL is in the comment here. And then we'll just add the term that we receive from the input by using backtick strings. Now what this returns is an observable to which we can subscribe, and as a parameter we're going to pass a callback which receives a response object upon success. To extract the data from there, we'll need to set this.tracks to be equal to response.json.results. And now you can see in the browser that we can execute the search with any term we want. Alright, we are being a bit optimistic here by assuming that we'll always get a successful response. So in order to handle the error case, all we need is to add a second callback, which will receive a response as well, from which we'll be able to read some properties. Now let's quickly import the response class from Angular HTTP. And if we type the response to be a response class, we see more clearly that we have access to a status, a type, status text, and a few more. Let's just log some of those values, and if we point the URL to a 404 page, we see the logs in the browser console. So this is the basic of dependency injection. It has two steps. One is to provide the HTTP client, and one is for the component to request it in the constructor. Now here we asked Angular to provide the HTTP providers inside the bootstrap method. Even though you'll see this done often in the bootstrap method, that's actually not exactly the right place. This parameter inside bootstrap is actually meant for configuring and overriding Angular's services. The right place to put application providers is actually within the application components, which in our case is within the iTunes app component. So in there we add a providers array and we move HTTP providers to that property. By doing so, the HTTP client will be available to this component and any of its children. So if you're familiar with Angular 1, you know that $HTTP used to return a promise. Angular 2 prefers observables when it comes to asynchronous actions. We will see in the last section how powerful observables are. But let's look at the http.get observable though. It can actually take a third callback, which is called when the observable completes. And if we simply log a message here, you can see in the console that this observable simply emits a single response and then it completes. This is about as close as it gets to the behavior of a promise. So since we're already learning a lot of new things, let me show you how to stick to promises if you're more comfortable with that. For this, observables have a toPromise method. For it to work, however, we need to add the toPromise operator by importing it. This is because in recent versions of Angular 2, the many operators of AJAX are not included automatically. Alright, once we do that, we can use the familiar .then and .catch API of promises. So in this video, we learn how to add providers to a component so that dependency injection can provide a built-in service. Making API calls inside the component is clearly not a good practice, however. And so in the next video, we learn how to create our own service. In the previous video, we used the built-in HTTP client to perform AJAX calls. In this video, we will extract that logic into our own service. We will start by creating an injectable. Inside that class, we'll make sure to have the JSONP client available. And finally, we'll make that new service available in the app component and use it to conduct the searches. So in the previous video, we injected HTTP providers at the root component level, and then we used the HTTP client straight there. But a component does not need to be aware of how data is being loaded. So we want to abstract the loading of data into our own service. I've already created the file and the class called search service. However, for a class to be usable with dependency injection, it needs to be decorated as an injectable. So we import that decorator and set it on the search service class. And don't forget the brackets. Now this service is going to have a search method, which takes a term as parameter. You may have noticed earlier that we didn't call the actual iTunes API. The reason for this is that the iTunes API does not allow for cross-origin requests, so HTTP would fail there. Instead, this time we're going to inject the JSONP service, and in the search method, we'll return this.jsonp.get. That's the only method supported by JSON with padding, and pass the URL which you find in the comment here. Now that would emit a response object, and we don't want the component to have to deal with that. So we'll map response to response.json.results. So now we're emitting the list of tracks only, which is all the component cares about. Earlier we used string interpolation to build a request. I want to do a bit better than that here. So let's create a params variable, which is a new URL search params. And now by using params.set, we can add key values to the request query string. So we set term, that's the key, and the value is term, which is the parameter in the method here. Now because this is a JSON with padding request, we need to provide a callback. So we'll set callback, and here we'll use JSONP callback as value. What happens internally is that Angular will take care of changing that value to a new callback name for each request. Now in the get call, we can add a second parameter, which is an object. That's a request option object. And we'll set search to be equal to these params we just built. So that's much cleaner than the string interpolation, and it also takes care of URL encoding. So by now you should expect that this isn't going to work since we have not provided JSONP anywhere. So let's head back to the app component, and inside providers we'll add JSONP providers in a similar way than we did for HTTP in the previous video. Of course, we'll also need to add the search service to the providers array so we can make use of it, and to dependency inject it, we'll use the constructor parameters. So now in the run the search method, we just call this.searchService.search and we pass the term. Then we subscribe to the response and set this.tracks directly to be equal to what the observable emitted, items. And you can see the result in the browser, and if you inspect your network, you will see under the JS filter the calls made to the iTunes API with the URL built from the params we provided and the callback name provided by Angular. So by doing this, we've completely extracted the loading of data into a separate service, and the component is unaware of any of the internals. Actually, all the component needs to know is that it will receive a list of tracks. Right now, if we were to go inside this.subscribe and change to this.tracks equals items 0.something, TypeScript has no way of helping us realize that we are coding wrongly. This is because items here is of type any. So even though tracks is expected to be an array of tracks as per the class property definition, well, maybe items 0.something is such an array. So let's make better use of TypeScript here. We know that search will return an observable, which itself will emit an array of tracks. So we should make TypeScript aware of that as well. To do so, we'll set the type of the return value of the search method. After the declaration of that method, we add :observable, meaning we are returning an observable. And more than that, observables are generics, so we can add angle brackets, array of tracks. And now when we head back to the broken app component, we can see TypeScript signaling that items 0.something is certainly not an array of tracks. Even trying to set this.tracks to items 0, for example, would tell us that we're trying to assign a track to what is expected to be an array of tracks. This can save you huge amounts of debugging time, so try and get used to typing your return values where needed. So in this video, we created a service which we then injected into the application component and learned how to make cross-origin calls using JSONP. In the next video, we'll see how providers can make dependency injection a lot more powerful. In a previous video, we created our own service and we made it available in the app component. In this video, we will discover injectors and the provide method. We will start by using provide to modify the built-in base request option. Then we'll provide a simple configuration value for the URL used by the search service, and we'll also make that dependency optional. I mentioned in the previous video that JSONP providers is a shortcut for a bunch of services needed in order to execute JSONP calls. One of those is request options, and currently it is set to base request options. But what if we needed to set some custom header on every request, or as is the case with the search service, we know that on every request we're going to need to add the parameter callback and set it to JSONP callback. Let's see how we could have that done automatically on every request. First, let us create a new class called JSONP options, which will extend base request options. And we're going to set search to a new URL search params, which we will instantiate with one query parameter already set, callback equals JSONP callback. So now let's make sure this gets used instead of the base request options. The providers array here actually tells the component to create a new injector, and when a certain class is requested, that injector will check whether it knows how to provide that class. Since providers is an array, the information that is added later will override or extend the earlier instructions. JSONP providers has already told the injector how to provide request options. To override this, we're going to append provide, and then the class request options, and then we'll add a second argument, and that's going to be an object. And that object will have a property useClass, and we'll set that to JSONP options. Translated, this means when the injector is asked to provide the request options service, please pass an instance of JSONP options. Now in the service, I'm going to dependency inject request options into the service, and when creating the new URL search params, let's either grab it from the default request options, this.ro, or set it to an empty URL search params if the search property wasn't set. And we can remove the set callback on the params. So using provide, we've replaced the implementation of one of the services needed by JSON-P. And you can imagine how we could use that to set default headers or perform authentication. You can also imagine how great this is going to be for testing, as we'll do in video 3.5. Now things are not always about classes. Sometimes you just want to provide a value. For example, why don't we make that search service configurable by passing the API URL? In the service, we'd basically want to ask for a dependency URL, but that's not a class, it's a string, so we can't use the type to tell the injector what we are looking for. For a case like this, we can import inject from Angular core, and you see that I've exported a constant called API URL. So we'll add the inject decorator to the parameter URL, so at inject API URL, and then set this .url to be equal to the URL value here. Back to the app component, we'll append provide API URL, and the second parameter will be an object with useValue this time, and we just pass the value that we want. Let's say the proxied iTunes API that we used previously. Before we check in the browser, currently if we don't provide API URL here, the dependency injection will break. So to make it optional for this config to be passed, we just head back to the service and we add @optional to the DI parameter in the constructor. If no provider is set for the API URL, the parameter will be null, so a quick if statement allows us to default to the original value set on the class. Let's check all that in the browser. With the provide value set, the calls are directed to Red Ape Solutions, and when not set, they are directed to the original iTunes API. Now hold on, did we manage to change a primitive that was declared as constant? Not at all. The injector that is created from this array of providers is like a book of recipes. And so what it did is it created an internal token that identifies API URL. And when requested in the constructor of the search service, the injector provided the value we set here. Now if this is confusing to you right now, note that you can also use a string instead of a variable or class here. For example, we could inject the string configurable API URL, and as long as we use that same string inside the provide method, it will still work. If you are interested in some of the internals of injectors, feel free to comment out the few lines below and follow the steps. So you can see how provide can help control the recipes that the injector is able to provide. One extra option of the provide method is multiple. That option allows to extend an existing set of providers. Have you noticed, for example, that we had to declare all the components and directives we are using in a component, like the track component here in this app? But we've been using ng-for, ng-if, and other directives without having to declare those. That's because Angular automatically adds a set of providers called platform directives to all components. Using multi, we're going to be able to add the audio directive to the set of core directives. Now since we're extending Angular's platform directives, the right place to code this is within the bootstrap method. So we'll add the array of providers and call provide platform directives, then we'll add use class audio directive, and we set multi to true so that we extend the platform directives instead of overriding that set. We can now head to the cool audio component, and even if we remove audio directive from that list, it will not break the code because audio directives is now a part of the platform directives, which are automatically set on the component. That's a very nice trick to keep the platform pluggable. So in this video, we used provide to modify or extend the recipes made available to the injector, and we also learned about the inject and optional decorators. In the next video, we'll talk about the hierarchy of injectors in Angular 2. In the previous video, we spoke about injectors and about the provide method. In this video, we will review the hierarchy of injectors. We will start by looking at how Angular 2 uses a component-based tree of injectors. Then we'll see how new injectors are created when providers are set, and how that affects children, parent, and siblings. Now the setup has changed a bit. I've added a track list component, which is going to be in charge of conducting the search. And the track row itself is made up of two components, track image and track details. So let's talk about how dependency injection itself is structured in Angular 2. Well, injectors follow the same hierarchy as the components themselves, meaning that the root component, app in our case, will have an injector, And then the search bar and track list will have an injector of their own. And then each track row created will have one, and each details and image within as well. Now, when a certain component requests a service, it will check whether its injector knows how to provide it, and if not, it will go up the ladder, checking the parent injector and the grandparent next until it finds a way to provide the service or reaches the top component. A dependency injection exception of no provider will be thrown if the top injector still doesn't know how to provide the requested service. Let's have a look at what that means in our app. At the top level, I've set a provider for a config value of use.jsonp, and in each component I've requested that same value and console logged it. Looking at the browser console, we can see that the moment the page loads, the app logs its value, and then its children's search bar and track list do the same. Let's execute a search and we see 50 logs, one from each of the track rows. For all these cases, the search for the use.jsonp recipe bubbled up to the root component's injector. So let's now head back to the code, and in the tracklist component, we will provide use.jsonp with a value of false this time. Looking again at the logs, we can see that app and search bar still have the true value, but the tracklist is now false, and so are all its children. That's because, as we set provide on tracklist for that use.jsonp token, when the track row components, and even the tracklist itself, when we inject use.jsonp, they look up the tree of injectors and they stop as soon as they find the recipe, and that happens when they reach the tracklist injector. In that case, it gives a value of false. Ancestors and siblings remain unaffected though. So this structure gives us great flexibility in the use we can make of dependency injection, for example for configuring providers at various levels as we showed here. One of the uses for this could be to create a form of private service for each track row. Let's have a look at that component template. Remember that for us to share data from the parent to the child, we needed to bind to an attribute and we need to have an input as it is coded currently. Well, instead of that, we could decide to have a service to hold the track object, which we could share within the parent and the children. Let's just create a very simple track holder service, and that will have a property called track of type track. Let's not forget to make that class injectable. Now at the track row level, we're going to add a providers array with track holder. And now we're also going to dependency inject that service into the track row. Now the track input will only be made available on component init. So ng on init, we can set this.trackholder.track equals to this.track. Let's remove the bindings here since we won't need them anymore and head to track image. We need to dependency inject track holder again, and on init set this.track equals to this.trackholder.track. Now thanks to Angular's hierarchy of injectors, a track image component will look at its own injector, fail to find track holder, so go one up, and that's going to be the track row component, which does have track holder within its list of recipes. And so basically the track row will share an object with all of its children. It could of course do a lot more than just holding the track object. So does that mean that services are not singletons anymore? Well, they are, but only at the level where they are declared to the injector, and for all the children of that level. So where would we declare a provider then? Well, that depends on each case. Just look for the lowest level at which you can afford a service to be unique. For example, if we wanted to keep a history of searches, we'd have to do that at the tracklist level, or maybe even at the app level, if we plan to route away from this page. A single track holder service, though, needs to be at the track row level. Providing at track details or image level would be too low, and they would not have access to the track model. Whereas tracklist level would be too high because it would create a singleton for all the track rows, and so all the track rows would share the same track object and everything would go wrong. So the flexibility and configurability of this hierarchy of injectors in Angular 2 is fantastic. It just takes a bit of getting used to find out at which level to provide the various services. So I mentioned in the previous video that another option of provide is use factory. So if you look at the logger.ts file here, I created a logger which can be instantiated with a prefix and optional stylings. If we tried to add logger to the list of app providers, the injector doesn't know how to instantiate this class because it doesn't know what to do with those two expected string parameters. So this is a case where we can use provide logger and then use factory, and that's going to be a function in which we can return a new instance of logger set up as we wish to. Let's change the implementation of the logger at the track list level. We could decide that from this component onwards, we'll use an alert logger, so use factory function and return new alert logger. Finally, let's head to the search bar component, and factories can actually also take dependencies. So we could say use factory and put, let's say, use JSONP as a parameter. And if use JSONP is true, we'll use one type of logger style and another type otherwise. So how do we pass these dependencies? We can add a depth array after use factory and pass the dependency inside use JSONP. Let's have a look in the browser. We get the alert from tracklist, and in the console you can see the styled messages, which for search bar depend on the value you've set for use JSONP at the app level. So you can see here the use of factories, which is when you need your dependency to behave differently depending on other factors. And you can also see again the power of the hierarchy of injectors. So in the next video we will make full use of everything we've learned about dependency injection to write tests for our service. In the previous video, we spoke about the hierarchy of injectors. In this video, we will introduce testing and use providers and injectors to mock services. We will first have a quick word about the testing setup and tools for Angular 2. Then we will be testing a simple model to get familiarized with Jasmine and that setup. After which, we will write and run tests for our own service, and in those tests, we'll override dependencies using provide, and even mock the HTTP backend. In terms of setup, Angular uses a slightly modified version of Jasmine. For the test runner, we'll be using Karma, and if you wanted to do end-to-end testing, you'd be using Protractor. Setting up the testing environment can be frustrating at times, so I strongly suggest that you don't try to set it up yourself. Instead, when working with an Angular project, it's better to use a generator or a seed project. Here are three of the common ones. The Angular CLI, which is convenient as a command line and has a lot of features. ng2 test seed is a seed repository with all the test features set up. And finally, Angular 2 starter, which is kept very well up to date with new versions of Angular 2. And to call the tests, all we need is to run npm run test, and that will execute a gulp task, which will run the tests on any file that has spec in its file name. I've already created a few tests, all of which fail at the moment. So we're going to start very simple to make sure that you are comfortable with basic Jasmine tests. We're going to test this model here, and in particular this from JSON, which basically takes a plain old JavaScript object and returns a track with the same attributes. So let's look at the spec file, which you notice is in the same folder as the track model. This is the preferred way to do things in Angular. Keep the test close to the related features. So here you can see that we are importing it, describe, and expect from Angular testing. Every test suite is created by a describe call and is described by the first argument here, track model tests. Then we get a function and we start creating the tests using the it calls. So the first one is to make sure that we get a track object out of a plain old JavaScript object. So let's create track equals to track.fromJSON, and we pass a plain old JavaScript object, and then we're going to expect the track to be an instance of the track class. So to check that it is true, we use to be truly. Next, for the second test, should copy all properties over. So we're going to once again create a track using the track.fromJSON, and we're going to pass a couple of properties. Let's use some that actually exist on the track model this time. And now in terms of assertions, we're going to expect track.trackName to be equal to hello and track.artistName to be equal to hi. In the Karma configuration, I've set AutoWatch to true, so the tests are constantly being rerun. So let's have a look in the console, and you can see that the tests we just wrote are now passing. Now that of course didn't have much to do with Angular, we were basically testing a class. So let's have a look at the specs for the search service this time. Since we're going to test search service, we need an instance of that class. For this we're going to use dependency injection, and it's already done here. We call inject
with the search service class, and Angular will create an instance of that service and provide it within this function as the search service variable. In this test, what we'll expect is search service.url to equal API URL since we didn't override the default. Now if you look in the console, you'll see a missing provider error. That's because none of the injectors knows how to build a search service. So in the same way that we add providers to components, we will need to add providers to the tests here. This is achieved with the before each providers method, which takes a callback that returns an array of providers. Here we need search service, but also in order to create an instance of search service, we're going to need JSONP. So let's add JSONP providers. Now when we do this, Angular knows how to build this search service, and so this test will pass. Next, within the test with settings, we'll want to override the API URL via the configurable API provider. But we can't do this at this high level, otherwise we'll be affecting the without settings test. So we'll add one more call to before each providers, and this time we'll pass provide configurable API URL and use value pick any value. Note that we are not providing JSONP again because that is already provided at a higher level. So the structure of providers in tests is a bit like that of providers on components. So now since we provide API URL, we would expect that the search service.url should be equal to that string value here. Now let's have a look at the next test. It should read data from the results array of the response data. Basically we're looking at the .search method this time. And that method is of course asynchronous because it makes a call to an API. So to inform the each statement here that it should wait for the asynchronous actions to be completed, we're going to make this inject async. And what we're injecting is the JSONP backend and the search service. Now you can see that backend is typed to mock backend. That's because we're going to override the providers for JSONP backend so that we don't actually make AJAX calls. So now here, after the JSONP providers, which itself provides JSONP backend, we want to override that JSONP backend. So we provide JSONP backend and we use a class which is mock backend, which we got from Angular HTTP testing. As a result, the JSONP backend passed to both our it function here and to the search service are actually the mock backend. So now in our test, we're going to execute a search with some term that'll return a promise, so .then, and we'll receive items. And we're going to expect items.length to equal, well, we're going to purposely pass 2 items, so we're going to make sure it equals to 2. Now the problem here is that the AJAX call might be going to the mock backend, but the mock backend right now doesn't do anything. So we need to intercept the connections, and backend.connections is an observable, so we can subscribe to it. And so every time a connection gets created, we will receive a new connection here, C, and that's going to be of type mock connection. And now we're going to fake the response by using mock respond, a new response which takes new response options, and we just need to pass the body as well as the status. Looking at the corresponding tests now, you can see that they are passing. Testing components is a little bit more complex, and so I'm just going to paste the code for the track list component. Remember the track list, we just load the list when we search, and then we create one track row per result. That of course is an asynchronous process, and here I've used async bracket inject instead of inject async. It's the same. And to test a component, we actually need to dependency inject the test component builder. And the first thing that we can do with that test component builder is to override providers on the tracklist component. And so to override the search service so that we don't need to worry about how it's executed asynchronously, etc., we just need to provide search service and replace it with a value, which is just a plain old JavaScript object that fakes the search. All it does is to return a promise that matches the signature of the normal search service search method. And then we just tell the component builder to create the tracklist component. That returns a promise, which resolves with a component fixture, which is kind of a wrapper around the component.
Now remember that we had a track components property on the track list component, which is a query list that keeps track of the track rows. So the first thing we'll do is to tell the component fixture to detect changes so that the track components gets initialized. Now the component itself is available as component fixture.componentRef.instance. And so on that instance, we're going to subscribe to the changes of the track components property. We will receive rows, which is all the track rows. And according to our fake search service above, we're going to expect the length of the rows to be 2. So now everything's in place and we execute the search. We receive a promise, and all we need to do here is to tell the fixture to detect the changes again. And now you can see that all the tests are passing. In this video, we coded and ran some tests on our service. This concludes this section about injectables and providers. In the next section, we will learn how to navigate through our app with the new Angular 2 router. Welcome to the fourth section, routing through the app. In the previous section, we took care of the business logic side of things using providers and injectables. In this section, we will learn to use Angular's new router to navigate through the app. We'll start by configuring routes and displaying the corresponding components on the page. Then we'll learn more advanced routes, including some with parameters, and how to retrieve and use those parameters. An important new feature of the router, which was released in the release candidate 1, is child routing, which leads to a better structure of routes. So we'll learn about how that works. And finally, we will cover lifecycle hooks, which are triggered at various important times of the life of our components and routes. In this first video, we'll start by declaring routes on our app component, and each route will have a corresponding component that it needs to display, which we'll do using the router outlet. Once routes are defined, we'll learn to enable the navigation either via simple links using the router link directive, or programmatically in our settings component using the router itself. So in order to achieve routing, we're going to import a few things, all of which are imported from Angular router, which by the way is not part of Angular core, so just make sure that you've npm installed it. So we're importing router providers, router directives, routes, which will allow us to configure the routes, and the router itself. Now the first step is to configure the routes. This is done by decorating the class with addRoutes, and that takes an array of definition of routes. Each route definition has a path, which is the URL, and a corresponding component to be displayed on the page. So I'll define the search, which will use the search page component, and the settings, which will use the settings page component. Now this tells the router that it needs to display those components, but it doesn't tell the router where to display those. So we're going to use one of the directives from the router directives, which is router outlet. And this basically says this component, search page component or settings page component, display it inside the outlet. Now to make sure that the router outlet is recognized, we need to add router directives to the list of directives. Next, since we're going to use the router itself, we need to add router providers to the list of providers, and we can then dependency inject the router into the constructor. Now once the component initializes, we're able to use this.router.navigate by URL, and we just pass the URL that corresponds to one of the routes. That would be, for example, /search. And then you can see in the browser that the moment the app loads, it redirects us to /search. So here we've set up our default routing. Now how are we going to allow the user to route? Well, we're going to use a link, and for that we're going to use a directive from router directives, which is called router link. It can be set as a simple attribute, and then the value will be the URL we want to route to. Or we can also bind it using the usual square bracket notation, in which case the value needs to be an array. And the first argument of the array is /settings, the URL. So now you can see in the browser that the two buttons allow us to route between the two views. Note that if we inspect those elements, there is a class called router link active, which is being toggled automatically, that is taken care of by the router link directive. So here we've allowed to route by using simple links. But if you look at the settings page, you can see that we're going to pick a country and then click save. So we will need to be able to route programmatically. To do this, let's head to the settings page component, dependency inject the router, and then in save we can do this.router. And let's use navigate this time. And navigate takes an array where the first element is the URL we want to navigate to. So now in the browser, when we go to settings, pick a country, click on save, and we get redirected to /search. Now you've noticed that when we routed, the URL changes, and that is actually using push state, which is not supported by every browser. So what if we wanted to use the more common hash segment in the URL? For this, we will import location strategy and hash location strategy from Angular Common. And inside the providers, after router providers, we're basically overriding the implementation of location strategy by using provide location strategy, use class hash location strategy. And now you can see in the browser that the hash is being used instead of the HTML5 push state. So in this video, we learned about basic routing setup and about navigating to the routes using either links or router.navigate. In the next video, we'll build slightly more complex routes that contain parameters. So far, our routes were all static. They did not depend on any parameter. In this video, we will route to a single track page, and so we will need the URL to contain the ID of the track. We'll learn how to pass such a parameter and how to read it from the component we display. We'll also learn how to append optional parameters to the URL. So you can see on the track list that each of the rows has an event track click, which then triggers a method called onTrackClicked. And so on that onTrackClicked method, we received the track, so we want to route to a page that displays information about this track. So in the app component, we're going to define one more route, and the path will be /track. And we need to pass the ID, so we're going to add a parameter, :ID. Then a component is just the track page component. Now if we go back to the track list and the onTrackClicked method, we'll use this.router.navigate. And I've mentioned that it takes an array. Now this array helps us build the URL. The URL has two parts. There's the /track and then there is the ID. So we set the first element to be /track, and for the second element we get the ID from the track object. Now you can see in the browser that when we conduct a search and then click on any of the tracks, the URL changes and it includes the ID of the track. But you can see as well that it says here's the ID, and the ID is not available inside the template. So how are we going to read the ID from the URL? Well, we're going to implement the interface called onActivate, so implements onActivate. And you can see straight away that TypeScript is not happy because we have not defined the router onActivate method. So let's define that method, and that receives a parameter which is a route segment. Now within the router onActivate, we can set this.id to be equal to segment.getParam, and the name of the parameter, which is ID as per the definition of the route. Now if you go to the browser, conduct the same search, and you can see that the ID this time is available in the new component. So just now we included a required parameter into the URL, that's the ID. We can't go to the track page without having the ID. What if we wanted to have an optional parameter when we come to the search page, which would pre-fill input? Well, let's have a look at the history page component. I've set it up that it just displays a list of terms which are fake history of searches. And so we want that to route back to the search, but we want it to pre-fill the input. So we're going to use a router link as before, and that takes an array, and we will route to /search. And the second element is going to be an object. And in here we can pass any key value. So I'm going to pass term as the key, and the value is going to be read from the template. It's the value of the term. And now inside the search page component, we can use router onActivate, which receives the segment. And we can set this.typeTerm to be equal to segment.getParamTerm, or an empty string if we don't find it. So now if we go into the browser, we go to history, and we click on any of the terms, you can see the URL changing, and it using a semicolon to separate the actual URL from those optional parameters. And then the value of the input is automatically set. So here we learned how to add parameters, either required or optional, to the routes, and how to read their value from the component. In the next video, we'll learn about child routing. In the previous video, we learned to add parameters to our route. As Angular 2's first release candidate came out, it introduced a brand new router, which is the one we've been using in this section. One of the important features of that router is the ability to use child routing. In this video, we'll declare new routes on a child component and see how they are extending the existing parent routes. We will discuss how this affects the router.navigate calls in order to reach those child routes, and talk about relative routing within the child component as well as back to the parent routes. So with this declaration of routes, we have set up routing to the main page's search settings history and to the single track page with its parameter ID. Now, structure-wise, what if we, in this track page, wanted to see subpages that show details, artist, album, and maybe have a link back to the search? Of course, we could declare new routes that contain details, artist, and album under the track/ID. But this is not what we're going to do in Angular 2, because the new router gives us child routing. So let's move to track page component, and what we're going to do is that inside this page we're going to declare a set of new routes. So we decorate the class with add routes, and this again takes an array, and we're going to define the first route with the path as /details and the component track details component. What's important here is that the path is /details. Now that doesn't mean that we're going to route to /details, because this is child routing. Means that we are extending the URL that took us to the track page component. So the URL will be track/ID/details. Then of course we'll do the same for the artist and the album. Now what do the corresponding router link look like? Well, we bind to router link, and this is an array. And we're going to route to ./details, which means go to details from within this track page. We then do the same for artists and album links. Now we're missing just one piece. We need to let the router know where to display these track details component, track artist component. So we need to set a router outlet inside this div. And by doing this, you can see in the browser, when we conduct a search, go to the track page. And now we can click on details, artist, and album, and see the outlet display the corresponding components. Now how does that affect the routing in our track list? I've mentioned before that the array inside navigate helps us build the URL. So now we have three components, /track, track.trackID, and we add details to say that we want to go to details when we click on the track. Now on artist click, we're just going to duplicate this and change it to artist. Now in the browser, if we conduct a search and click on the image or on the track in general, we go to the details, and if we were to click on the artist name, we go straight away to /artist. So let's go back and have a look at those links. You can see that we are routing to ./details./artist. In general, / means append this URL to the current URL. But you can see that when we click on album and then back to details, we're not appending album details each time on the URL. This is because / here refers to the root URL of the track page component. So the links will always be track/ID and then /details/album, etc. So this introduces relative routing, and this leads us to implementing the back to search link. Remember, we are referring to the root URL of the track page component. So how would we go back to search? We need to go 2 levels up, one for the ID and one for /track, and then /search. The router in Angular 2 Release Candidate 1 is a complete revamp of the previous router. And notably, it doesn't allow to pass data within the navigate method. So how do we handle this? How are we going to share the ID between the track page component and the subviews? Well, remember what we did in the previous section on providers and injectables. I've created a track holder injectable here, to which we can pass a track ID. What we're going to do is in the track page component, the top component, we're going to add track holder to the providers, and that will create an instance of the provider at that level. Then we will dependency inject it into the constructor. And on router activate, we are going to set the track ID of the track holder to be equal to the ID we read from the URL. Now if we go to track details component or any of the other two components, we can dependency inject track holder, and then on ng-init we can read the track ID from the track holder and set it onto the ID of this current component. As you do this, you can see in the browser that the ID is now displayed in the track page component as well as in the track details component. This is how we can share data between the routes by using the tree of injectors. So here we learned about child routing, which helps us structure our routes better. The routes that belong to a single track, for example, don't need to be declared at the main app level. They are independently created at the track level. In the next video, we'll talk further about lifecycle hooks of Angular components and routes.
In the previous video, we used child routing, which allows us to structure our routes better. Let's now look into lifecycle hooks.
We'll first define what lifecycle hooks are and review a list of Angular core hooks. We will then implement a few of those hooks on one of our components. The Angular router also defines some hooks of its own, and will implement one, namely can-deactivate, which is an asynchronous hook, so slightly different. Angular has a set of lifecycle hooks for components and directives. Lifecycle hooks are methods which we can decide to define on our component, and if they are available, Angular 2 will call them at important moments in the life of our component. You can find a list of these hooks at this URL, and they are called in this specific order. So ng-on changes, which happens whenever a change occurs for the input properties of a component. ng-on init, which happens only once after the first ng change. If we use content projection, we will have ng after content init and after content checked available. And then for components only, since directives don't have a view, we can also define ng after view init and ng after view checked. ng after view init will be called after the component's views and the child views have been initialized. And of course the last one, when Angular destroys a component, ng on destroy can be called. So let's have a look at a few of these lifecycle hooks. Here in the tracklist component, I have imported after view checked, after view init, and on init. Those are all interfaces. So we're going to go to the component class and we're going to mention that it implements those interfaces, after view init, on init, and after view checked. Immediately you can see that TypeScript is not happy because we did not define the corresponding methods. So let's do this. We'll start with ng on init. And here I'm just going to console log init. And also this property that we have on the component, which is this.track components. Remember, it's a query list for every track row. Next, ng after view init, going to console log track components.length this time, so the length of the number of rows. And finally, ng after view checked. And for this one, again, just a console log with checked and the track component. So just a word about implementing interfaces. We don't actually have to let TypeScript know that we are implementing those interfaces. But it is really good practice to make full use of strong typing and editor capabilities. Alright, so let's have a look at this in the browser. And you can see that when we reload the page, we first get an init with undefined, then 0, which is the current length of the track components, and then a series of checked logs with the query list, each of them with 0 results because we don't have any track rows at the moment. If I conduct a search, you can see that the last checked has an array of 50 results corresponding to the track rows that we have just created. Now the Angular components are not the only ones that have lifecycle hooks. The router, for example, defines its own hooks we have already used on activate. An interesting one is can-deactivate, which is called when we try to route away from a certain component. So let's go to the search page component and let's implement can-deactivate. Now of course TypeScript is not happy because we haven't defined router can-deactivate. But this is not enough because can deactivate must return a promise which resolves with a boolean. So here we're going to return a new promise with resolve, and let's pretend that when we get away from the search page we actually preload data. I'm just going to set a timeout and resolve with true. Now to make it a bit more obvious, I'm going to console log loading as we start and console log done loading after the 3 seconds. Now if you look at it in the browser and you click on an artist, you can see loading and then 3 seconds later done loading, and we are routed to the other page. Now of course if I had resolved with false and we do the same, you can see loading, 3 seconds later you can see done loading, but the router knows that we shouldn't route away. I've mentioned in a previous video about watching changes as opposed to two-way binding. So let's have a look at the onChange lifecycle hook. So here in the search bar component, I've imported onChanges and simple change. So the search bar component is going to implement onChanges, and we're going to define the ng-onChanges method. Now the argument for the ng-onChanges method is an object, and that object will have the keys of all our @input properties. Like here, for example, we have term, and then the value will be a simple change object. So all I'm going to do is console log the corresponding change for term. Let's have a look at that in the browser. I start from history and click on any of the links, and you can see here the simple change with the current value and the previous value, which is actually empty. Now if we type something into the input, you can see another simple change, and this time with a current value and the previous value set. In this video, we learned about the optional component methods called lifecycle hooks, and saw a few examples of core hooks as well as router-defined hooks. This concludes the section on routing, which allows us to create several pages in the application and navigate between them. In the next section, we'll talk about pipes, which are declarative transformations of the data straight in the template. In the previous section, we learned to navigate through the various pages of our app using the Angular router. In this section, we will talk about pipes, which are a declarative way of transforming data straight in a template. We will start by using pipes that are bundled with Angular 2 in the common module. We will then learn how to create our own pipe to be used in our components. We will talk about pure and impure pipes and see how we should mainly stick to pure pipes. Finally, we'll make use of the async pipe and extend it to see some of its internals. In this video, we will go through some of the built-in pipes of Angular. We will learn how to pass parameters to those pipes, including values which are data-bound to component properties. Then we'll show how to chain pipes and apply several transformations to the data before displaying it. Pipes allow us to transform the way data is displayed from within the template. This allows for simple and declarative manipulation of data. Angular 2 comes with a set of built-in pipes, including date, currency, %, uppercase and lowercase, as well as some pipes focused on arrays like the slice pipe. All these are automatically added to every component for us to use. Now on the track interface, we now have a release date property, which is a date object. Let's display that on the track component. If you go to the template and you use the double curly brackets and track.releaseDate, if you look in the browser, you can see that it displays an ISO format, which is not very friendly. So back to the template, we're going to pipe that using the pipe operator into the date pipe. Now, immediately in the browser, you can see that the date is formatted in a much more friendly way. Pipes can also take arguments. To pass an argument to a pipe, we would use colon. And then for the case of the date pipe, we can pass short date or long date. And in the browser, you can see that the date is now formatted differently. That format actually depends on your locale, by the way. The date pipe can also accept custom formats. You can find a reference to the corresponding symbols here at this link. For the year, we would be using Y, and for the month, capital M. Let's say I use 4 M's, that's for the long form of the month, and then Y for the year. And you can see in the browser the full month and then the year. And just because we are passing parameters to a pipe doesn't mean that we can't use data binding. For example, here we could set that the format is bound to the date format property, which I have set as an input of the track component here. If we now head to the tracklist component, we need to bind on the track row. Using the square bracket, we bind to the date-format property, and we make that equal to date format. The value of date format at this level will be changed by those two input radios. It will be either short date or long date. Let's have a look at that in the browser, and if you click on any of those two radio buttons, you can see the format of the date changing. One more feature of pipes is that they can be chained. So for example, after formatting the date to our date format, we could pipe that further into, let's say, uppercase. And now in the browser, you can see the date being formatted and then uppercased before being displayed. Two quick things for the extra. First, you may have noticed that when I mentioned built-in pipes, I did not mention a filter or a sort pipe. This is because Angular 2 does not provide such a pipe. It is not an oversight. There's a very good explanation for this at this link. The main reason for this is because such filter pipes or sort by pipes have a major negative impact on performance when they are misused. Now a second extra, which is actually unrelated. Let's head back to the browser, click on a song, and if you click on the artist, you can see that nothing happens. And if you were to open the developer console, you can see that there's an error which is cannot read property artist name of null. So let's head to the code and see what's going on. In the artist component in the template, you can see that we are binding to track.artist.artistName. Now if you look inside the artist component implementation, you can see that on init we are first loading the track, and then once we have the track, we get the artist. Which means that up until this stage, track.artist is actually null. This is what causes the error. Angular 2 provides a very convenient operator called the safe navigation operator, also known as the Elvis operator, and you can use that by adding a question mark to any property which you are not sure might be null or undefined. So here, for example, add the question mark on track.artist, and when the template binding is evaluated, Angular basically checks whether track.artist exists before trying to read the artist name property. And now in the browser, you can see that this works as expected. In this video, we use built-in pipes to transform data from the template. In the next video, we'll create one such pipe ourselves and use it in our component.
In the previous video, we learned to make use of built-in pipes. In this video, we are going to create our own pipe. We'll make it available to the component and use it in the template. We will then modify our pipe to add parameters to its definition. If you look in the browser at the current version of the app corresponding to the bundle that was provided for this video, you can see that under Artist, we now display the list of albums of that artist. And the list of albums shows a price. But for the price, it shows GBP as opposed to the pound sign. So we're going to write a pipe which takes this 3-letter currency code and makes it into the currency symbol if available. I've already created the pipe file currencySymbol.pipe under the tracks track page folder, and I've imported pipe transform, which is an interface, as well as countries from the settings. That's just for us to match the currency code to the currency symbol. So to create a pipe, we need to use add_pipe, and a pipe needs a name. This is what we'll be using in the template. So let's call it symbol. And then we export class, let's say currency symbol pipe, and we're going to specify that it implements the pipe transform interface. As usual, specifying that it implements an interface is optional, but is good practice. Now in order for us to fulfill that interface, we need to declare a method transform, and that will take the value from the template as a first argument. So let's say currency, which is going to be a string, and we're going to return a string as well. Now for the internals, I just paste it here. Basically we go through the countries specified in settings, we try to match the currency, and if we find it, we get the symbol. So at the end we just need to return the symbol if we found it, and the original 3-letter code if we didn't. You can have a quick look at the countries, and you can see that the US and the UK have a currency symbol, whereas Switzerland doesn't. Now that we've created the pipe, let's use it in the artist component view. First we need to import the pipe class, and then in the template on album.currency we pipe into symbol, symbol being the name that we selected in the add pipe. One more thing is we need to specify which pipe is being used.
That is done by adding an array of pipes in which we add the currency symbol pipe. Let's switch to the browser and you can see that the pound is now being displayed instead of GBP. If we go to settings, change to Switzerland, conduct a search, which by the way, as you can see, yields different results because we are pointing to a different iTunes API. And now under the albums, the price is showing CHF because Switzerland doesn't have a currency symbol in our settings. So this is a simple pipe. Now let's see how we could add arguments to that pipe. I'm going to change that now it's the collection price that we will pipe into the symbol. And as a first argument, we're going to pass the currency. And just to add a feature, we're going to pass one more argument, so another colon. And we're going to pass whether we want to display the symbol before or after the price. So now our currency symbol pipe, the signature needs to be changed. First we receive the price as a string. And as a last argument, we will receive a boolean, which is optional, before. The symbol will now be set to either symbol or currency. And if before is set to true, then we return the symbol followed by the price, and the price before the symbol otherwise. Now if you do a search and look inside artist, you can see that the code is still there, and it is displayed before the price. Let's change the before value to false, and why not switch the settings to the US. And now you can see that the dollar symbol is being used, and it is displayed after the price. So that's how we make a slightly more complex pipe with arguments. Two quick extras. For the first one, let's talk about ES6 spread operator. Let me create a pipe. I'll do that in search page because it's the first page that we access. So add pipe, and I'm going to name it add, and export class add pipe. And the job of this pipe will be to take an initial number and to add any number of arguments that we pass in the template. So in the transform method, we will have the initial value, which is going to be a number, and then we're going to use ... args, which is the so-called spread operator, which means take any other number of arguments and put them into an array called args. So it's very simple. Args is an array, so args.forEach. For each n, we will just add n to the initial value, and we return the final value calculated. Let's quickly add an example of this in the template, which is going to start with, let's say 4, pipe it into add, and then just pass any number of arguments, let's say 5, 10, 20, and 3. For this to work, of course, we need to add the pipes array with the addPipe class. Let's have a look at this in the browser, and you can see the result of the addition of all our arguments to 4. For the second extra, let me open boot.ts. And you remember how we extended platform directives by using provide? Well, we can do the same with something called platform pipes. Right, we'll just use provide platform pipes, and then an object, use value, and this time we're going to pass an array because we want to add several pipes. And in here we will put our custom pipes, which are add pipe and currency symbol. Don't forget to set multi-true so that we extend platform pipes instead of overriding it. Of course, let's quickly import those two pipe classes. And now, even if you were to remove the pipes array from search page component and from the artist component, the two pipes are still available because they are part of platform pipes, which is provided to every component.
In this video, we learned how to declare a pipe using the addPipe decorator. We also made it a bit more advanced with parameters. In the next video, we'll talk about pure and impure pipes. In the previous video, we learned to build a custom pipe. In this video, we are going to implement a filtering pipe to segregate songs and movies from the iTunes API. And we're going to accomplish that in two different ways. One of the two implementations will have to be made into an impure pipe to work, and we will see why that's a bad idea in terms of resources.
So on the tracklist component, I've added two new properties, filters by type, which is a string, and filters, which is an object which itself contains a type. What we're going to do is implement two pipes for filtering by type, one called filter type and one called bad filter, which will be an impure pipe. Now here I've set 3 radio inputs, which will allow us to change between the type. You can see that on click, we're doing two things on each of those radio buttons. We're changing filter by type to a value all, feature, movie, or song. And we are changing the type property of the filters object to that same string. So let's implement the first type, and the name is filter type. So then class filter type, and we need to provide a transform method. That transform method will receive the list, which is an array of tracks, and the filter, which for this one is a string. The second pipe, with the name bad filter, is very similar. It also has a transform method which receives the list, again an array of tracks, and filter, which I'm going to set to any. It's actually an object with the property type. Now the implementation is very straightforward. List is an array, so we are going to return list.filter, and for each item we're going to check whether the kind is equal to the string that we received from the pipe. Just one more thing, if filter is equal to all, then we return the original list. Now the bad filter is exactly the same, except that filter is an object here and it has a .type property, so that's what we compare with. So you can see that the two are extremely similar. However, one of them is going to be a good, pure pipe and the other one won't. And so here in the template we are going to have two columns. On the left is going to be the filter type, and on the right will be the bad filter. Now to make sure that the pipes are recognized, we need to add the pipes array with the two classes. Alright, so let's have a look in the browser. I'm doing a search, and you can see that the result contains movies as well as songs. Now if we go to our filter type and click on songs, well, you can see that the left hand side works, but the right hand side doesn't. Now this is because Angular only re-evaluates pipes if a pure change has occurred on one of its input parameters. What we call a pure change is a change in the reference to the object. Now in the case of the filter type, filter is a primitive, and so it changes the moment we set to a different value. However, in the bad filter, the filter is an object, and so we are mutating that object, not changing the reference. To the pipe, this means that there was no change. One way to force this pipe to reevaluate itself is to make it impure. To do that, we just set pure to be false in the pipe metadata. Before I continue, I'm going to console log bad inside the bad filter and console log OK in the other filter. So let's do another search and click on movies and songs, and now you can see that both sides are working. So that seems pretty okay. However, let's open the developer console, and you can see immediately there are tons of console logs of bad and very few of OK. And it gets worse. If we clear, anytime that we do anything on the page, like typing in the search input, Angular has to reevaluate the pipe. So using an impure pipe is extremely dangerous, because at every change detection cycle, Angular has to reevaluate that pipe. So really, in most cases, stay away from impure pipes. So now the first pipe that we created works perfectly fine. So you might wonder why there are impure pipes, and what's the fuss about? Well, the pipe works well because it fits our needs. But let's say we wanted to implement a button whose job is to mark all the results as songs. So on click, we're going to call mark all as songs. And the mark all as songs method is going to do this.tracks.forEach, and on each item set the kind to song. So here we are mutating the objects inside our array. I'm going to do a search, go to movies and songs, you can see the list, and now I click mark all as songs, which means that inside movies I should not see anything anymore. And yet nothing happens. Why is this happening? Because the input value for our pipe is the array. And when we mutate the objects inside the array, we are not changing the reference to the array. Therefore, Angular does not reevaluate the pipe. So how could we get around that? But we just need to make sure that we pass a new array so that the reference changes. To do that, we can simply change this to a map, and inside the callback we set the item to be song, and we return the item. So at the end of the markAllAsSongs method, we have a new array. In cases like this, it's probably better to just stay away from pipes. Pipes are really meant for simple transformation of displayed values. It's better to keep the logic inside the component instead. In this video, we learned about impure versus pure pipes, and that we should, most of the time, stay away from impure pipes. In the next video, we'll talk about one case of acceptable impure pipe, the async pipe. In this video, we'll use the async pipe to observe an object, which could be an observable, a promise, or an event emitter, and display the latest value it emits. We will extend the async pipe so that we can have a look at its internals. We're going to implement the list of recent searches. We already have a history search service which takes care of that, and so we will consider recent searches to be modified asynchronously. For now in the template, we're just using an ng4 on a history array, which is currently empty. So we're going to use the async pipe, which allows us to keep watch on a promise, an event emitter, or an observable, and to react accordingly. So let's look back at our history service. You can see that the searches is just an array, and whenever we conduct a search, we can add the term. So what we will want to do here is to emit the fact that a new search has been added via an observable. Now, because we need this observable to also be able to emit, we're going to use a subject. We could very well use an Angular event emitter, but we've seen that before, so let's use something different, a subject. And then when a new search is being added, we're going to do this.searches.o.next and pass the current array of recent searches. By the way, it's good practice to specify generics, so here it's going to emit arrays of strings. Now back to the search page component. On init, we can set this.history to be equal to this.historyService.searches.o. So we are referencing the observable. Now to make this work, we can pipe history, which is the observable, into the async pipe. And the async pipe will keep track of whenever a value is being emitted, and it will set this history pipe async will be equal to the latest array that has been emitted. Now before we have a look at that in the browser, let's create our own async pipe, which extends the original async pipe. So the constructor must take the same signature, and that receives a reference to the change detector. What we're going to do is simply console log, and then don't forget to call super with the same reference. Now the transform method receives the object, which can be an event emitter or a promise or an observable, but in our case is a subject. And just to see a bit more about the internals, the async pipe keeps track of a subscription. So we're going to write if not this.subscription, we're going to console log that we're subscribing once. And then so that we can see whenever something happens, we're going to add our own subscribe to the object. And here we're just going to console log check and the array that has been emitted. Again, don't forget to use super to call the parent method. Now if we add the pipes array with the myAsyncPipe class, this pipe will override the async pipe and we will see the console logs. Let's head to the browser with the console open. You can see the creation of the pipe, and you can see that we are subscribing once. Then every time that we run a search, we can see check and the array of new searches. Now the async pipe is an impure pipe because the object doesn't change, the reference never changes, and yet we reevaluate the pipe when the object emits anything. Now the reason why the async pipe is great, even though it's an impure pipe, is because it reduces boilerplate. For example, if we wanted to achieve the same without this async pipe, we would basically subscribe to the subject, and then whatever items we would receive, we would have to set to a property on this object. Also, when the component is being destroyed, so on ng-on-destroy, we actually have to remove all the subscription to observables. Async takes care of that for us. So you saw that the async pipe has a reference to the change detector. So let's talk a bit about that change detection and how we can actually help Angular avoid unnecessary checks. Let's head to the track component, and on after view checked, I'm just going to console log track has been checked, and I'm going to do the same in the track list after view checked. Let's now look in the browser, and you can see that the list gets checked relatively often, and since we receive 50 results, we get 50 tracks, and so we see 50 console logs. So far, nothing special. However, if we now type in the input, you can see a lot of checks being executed on the existing tracks. By default, on every change detection cycle, Angular assumes that we need to check every component. So how do we tell Angular that it does not need to run all these checks? On the track list, we're going to set the change detection property. We're going to set that value to change detection strategy.onPush. And the onPush actually means wait for me to tell you that you need to check. Now, if you look in the browser, you will see that, well, we can conduct a search and we don't see the tracks being checked, but we also don't see the tracks being displayed. That's because we told the component, wait for us to inform you that a change has happened, and we never did. So here we're going to dependency inject the change detector reference into the track list. And when does the change happen? That would be here in the search method after this.searchComplete. So let's inform the change detector, this.cd, that it should mark this component for check. And now in the browser, you can see that we can conduct searches, they appear, and when the next change detection cycles happen, the list is checked, of course, but each track is not. So by doing this, we can really improve the performance of our app. So in this video, we learned how to use the async pipe to display values emitted by an observable or a promise. And we also introduced change detection cycles and the change detector. This concludes the section about pipes. We learned to use built-in pipes, create our own pipes, and learn about the difference between pure and impure pipes. In the next section, we will look into forms in Angular 2, including custom and asynchronous validation. In the previous section, we used pipes to transform the way data is displayed straight from the template. This section will be all about forms. We'll discuss how we can build relatively complex forms purely via the template, including basic validation and even interaction between inputs. Then we'll get the model actually involved, so we'll move most of the logic away from the template and into the form model. Slightly more complex, but way more powerful. Finally, we'll look into custom validation, including asynchronous validation. In this video, we are going to build a form purely from the template. For this, we'll use the ngForm directive. We'll also bind the various inputs to the value of the form using ngControl, and structure the outcome value using ngControl groups. We'll show how purely from the template we can enable basic interactions between controls. And finally, we'll use validators, check form validity, and display error messages. So we're going to improve the settings feature by implementing profiles. Here on the left, you can see what a profile is expected to look like, except for the name, which is an identifier in the DB. It has a localization object with display currency symbol, that's a boolean, and a country. It also has details with first name, last name, and initials, and finally the number of items to be kept in the history. Down here you can see that I've already set up the select list checkbox and inputs needed for this form. So let's see how we can wire that up purely from the template. It all starts at the form tag. Here we can reference a local template variable, let's say hash the form, and make that equal to ngForm. By doing this, we now have a reference to the form directive. And to keep track of what the form value looks like, let's pipe the form.value into that JSON pipe here. Now the form controls are represented by a directive called ngControl in the template. So we can simply go to, let's say, the first name and add ngControl equals to first name. That also works on select lists and checkboxes, so let's add it here for the country. And you can see on the right hand side that we have country and first name, and if we were to select a country, the corresponding value is added to the form value. So that's already a great start. But you see that the country is actually under the localization object in the profile object. So does that mean we're going to have to wire all that up together on form submission? No, we can actually use another directive called ngControl group and set that to the value localization. Let's also add the ngControl for the display currency symbol here. And now you can see that the form value has a property localization, under which we find the country and display currency properties. So let's amend the template so that the structure matches the profile exactly. We need one more group, which is details. And then we add ng control on the last name and the initials. And finally, we add the ng control on the max number of items in history. And now we have the exact same structure between the form value object and the profile object. So that's going to make it very easy to save to a database or submit it to a server. Now just now we set a local template variable, the form, to be equal to ngForm. But that's not limited to the form tag. We can do that on any ng control group as well as any ng control. So for example, here the control group details, we could call that hash details chunk equals to, and that's still ngForm. Value here doesn't change. And then on the control, maybe hash fn equals to ngForm. And now we could easily show that fn.value corresponds to the value of the first name input. So what can we do with this? Well, we can make controls interact. For example, let's set hash ln to be equal to ngForm on the last name and hash I for the initials. And now let's say that when we change the value of the first name or the last name, we're going to update the initials. So we can bind to the change event of both the first name and the last name. And we're going to use i.control.update value. And then a bit of logic. If fn has a value, then we try to grab the first letter. And the same for the last name. So this allows for a bit of logic in the template. It's nice because it's declarative. Let's make sure to keep it to a reasonable amount. So what about validation? Angular comes bundled with a few validators. A very common one is to set a field to be required, and each validator comes with a corresponding directive. So here, for example, all we need to do is to set required on the input. A slightly more complex one is the pattern validator. Let's use that on the first name, where I only want to allow letters to be used. So we'll set pattern equals, and here we provide a regular expression for Angular to use. Now how do we know about the state of the form? Well, not just at the form level, but at any ng control and ng control group level, we can actually refer to the valid property. So here at the form level, we're going to display, instead of false, I'm going to change that to the form.valid and the form.pristine. And let's use valid here at the details level. We're going to toggle a class if the details chunk is not valid. Finally, how would we display the corresponding error? Let's add a message here in a span, and we're going to show that only if the errors have a pattern property. This will be set by the pattern validator. This actually gives us access to the error object itself, which in the case of a pattern validator has a required pattern property, which we can display here in the error message. You can see that as we type the first name, as long as we use only letters, everything's okay. And then if I use a space, the error class gets toggled and the error message gets displayed. At this stage, the form is still invalid, as you can see up here, because we don't fulfill the required on the max number of items in history. Let's set a value here, and the form changes to valid. So as you can see, there really is a lot that you can do from within the template. You just have to be careful not to use too much of logic inside the template. Now this is the first time that we're able to assign a local variable to a directive ngForm. So far, the hash template variable only allowed us to reference the input itself or the element itself. So let's see how that works and use that in our own directive. Remember that we have a cool audio component inside the tracks. And to enable that behavior, all we need to do is to add the property export as on the component and give it a name, let's say cool. Now in the track component, let's add a cool audio component again. And this time we can set, let's say, hash c equals to cool. That's the name we just picked for the export as. And from within this component, we're now able to use c.play or pause any of the methods that are available on our component cool audio. So that's how we are able to reference to the directive itself by using export as. So in this video, we created the form entirely via the template. In the next video, we'll get the component involved via the form model.
In the previous video, we learned to build a form where controls and control groups were simply added to the template.
In this video, we'll build a model that matches our form structure. We'll learn how to create and access controls and control groups, and we'll also look at ngForm control, which offers an intermediate solution between having no access to the control and rebuilding the entire form. Finally, we'll look at observing value and status changes on controls. So how do we interact with the form programmatically from the component? First thing we can do is go very low level and bind to the data by using ngModel. So here, for example, we could bind ngModel 2A to profile history max. Controls and control groups offer a lot more than just data binding though. So let's see how we can make full use of that. When we added the ngControl and ngControl group directives here, basically Angular created a form model, and in that form model added the groups and the controls accordingly. But that doesn't give us access to that form model. So here instead we are going to provide the form model. So we bind to ngFormModel, and we're going to bind the entire form to the profile form property of the component. Now the ngControl and ngControl group directives remain, but Angular now expects to find them inside that profile form. Let's take care of that. You can see that we have dependency injected the form builder. And so we're going to set this.profileForm equals to this.fb. And we're going to create a group, because in the end, the entire form is actually just a group, just like the details group and the localization group. Now here, to create the group, we need to match the structure defined in the settings page template. So remember, we have a details, which is also a group, and that contains 3 controls: first name, last name, and initials. Here I'm going to show you the 3 different ways that we can create a new control. First is to use new control, and the first argument of that new control is the initial value. Another way is to use this.fb.control, and the signature is the same. And finally, which is why the thisfb.group can be quite convenient at times, we can simply pass an array, and Angular will create the control for us. We also need the localization group, and that has 2 controls: country and display currency symbol. Now for the country, for us to initialize the value, make sure that you point to the actual country object, not an object with the same values. So for this, we'll use a find on countries and match by their code. And finally, by itself, history max, which is just a control. In the template, we still need the ngControl and ngControl group names, because this is how Angular is going to match with the groups and controls that are found in the model. Note that if there's any mismatch between the ngControl and the actual controls that you have in your model, Angular will throw exceptions. Now what if we wanted to make use of a specific control, but we didn't want to rebuild the entire form? You can see here that I have another form which corresponds to the select list in the top left, where we can switch between the default and other profiles. So let's say I wanted to access this viewing which control without necessarily rebuilding the entire form. There's a directive whose feature is kind of in between the ngControl and the entire ngForm model, and that is called ngForm control. We can bind that to any existing control on the component. In the browser, you can see now that the default is being selected. One of the possible reasons for accessing a control programmatically could be to keep track of the value changes. Amongst other things, controls have 2 observables, one which emits value changes and one which emits status changes. So here we could write this.viewingWhich_control.valueChanges, and that's an observable, so we can subscribe to it. We'll receive a value every time that it has changed, and in this particular case we could use that to load the corresponding profile when we change that select list. And here in the console, you can see every time that we change the value, we get 2 logs, one for the new value and one for the current status, although here it's always valid. What if we wanted to programmatically access one of the groups or the controls that we have created here using the this.fb.group? For this, we can use the group.find method. For example, if we wanted to grab the details group, we could use this.profileform.find and then details, which is the key to the group. Note that TypeScript is not very happy because find returns an abstract control. All we need to do is to cast it using as control group. And if we need to access a control, which let's say is within another control group, then we use this.profileform.find and pass an array. And that should contain the strings that correspond to the property, so details, comma, and then first name. Again, we cast it to control this time, and so now we have access to the first name control, which was created earlier. So there are basically 3 different levels to interact between the component, the form, and its controls. The first one is ngModel, which goes straight to the data and doesn't give us access to the controls themselves. The second one is to completely recreate the ngForm model, and that will have to match all the control groups and all the controls set in the template for that specific form. And finally, the last one, when we want to access one simple control and make use of that in the component, we can use ngForm control. So what about form submission? We haven't submitted yet. So on the form, we're going to bind to ngSubmit and simply specify which method we want to call. We can pass the form.value, or in this particular case, since we already have ngForm model bound, we don't need to pass anything. Now, why are we not binding to simply submit? It's because Angular doesn't want to override the behavior of things. On the normal submit event, if the method here that we call raises an exception, the form will still be submitted. With ngSubmit, the submission is stopped. So you can actually use both. It depends which behavior you want. In the component, we just receive the form, and let's just save the profile. Let's quickly add an alert and then try it in the browser. And you can see that the changes are persisted even after refresh. So now that we have programmatic access to controls, let's re-implement this setting of initials from the first name and last name, but this time using observables. First, we're going to assign the last name control and the initials control in the same way as we did with the first name. And now we're going to use observable.combineLatest, which accepts any number of observables. We're going to use the first name control.valueChanges and the last name control.valueChanges. And that gives us a new observable which will emit any time that either one of those 2 observables emits a change. Since it's an observable, we can subscribe to it, and we'll receive values, which will be an array. Now we're going to explode that into first and last values using this nice TypeScript notation. Now if first is not an empty string, we take the first letter and we uppercase it, and we do the same for last. And finally, we concatenate them into the initials. Let's have a look in the browser, and you can see as we type that we get the change in the initials. Now this is one of many ways to do it with these observables. If you look at the extras bundle, you will find an alternative implementation where everything is explained using ASCII representation of the streams of data. So in this video, we programmatically built and controlled our form. In the next video, we'll talk about validating the form.
In a previous video, we leveraged the form builder to create a model that matches the structure of our form and interacted with controls and control groups. In this video, we will look at the many ways to validate the form. We'll start by adding validator functions onto a control, then we will combine several of these validators. And each time we'll see how error display is handled on the template. We'll create a custom validator and finally create an asynchronous validator for the form control. Before we start with the validation, let me just mention that everything in the settings service has now been made asynchronous. So the loading of profile names, each profile as we change the select list, all of that returns promises. Also, the template validations, required and pattern have been removed. So let's start with simple validation. How would we make the last name required? All we need is to type this.lastnamecontrol.validator, and we just set that to validators.required. Validators.required is a function which will be called every time that a change occurs on last name, and if that control is valid, it just returns null. How about the pattern on the first name? This.firstnamecontrol.validator is equal to validators.pattern, and here we need to pass the pattern to that function. Now that validators.pattern function itself returns a function which follows the same behavior as validators.required, null if everything's okay, and an object if not. Earlier in the settings page.html, we had this help block, which was looking at fn, that's the reference to the ngForm directive, and checking for errors and the pattern.
Now using the control itself, it's a little bit different. Instead we'd use firstName control dot has error, and we pass the string which corresponds to the error we're looking for, pattern. And then to access the error itself, it's firstName control dot get error, pattern, and then it gives us the same object which has required pattern. We can do the same on the last name control with the error key this time is required. Now you can see that the validator takes only a single function. So what if we wanted to apply several validators on the same control? Let's do this on the initials control. Right now we don't have a reference to that, so let's grab it from the profile form.find, and the path to it is details initials. Now to combine the validators, we're going to use validators.compose, and to that method we can pass an array with any number of validator functions. For the initials, we're going to enforce a minimum length of 2 and a pattern which is only capital letters. So how are we going to display that in a template? Well, to decide whether we display any error message at all, we're going to check whether initials control is valid. And then we can have two spans, one for initials control.hasError with the key pattern, so that will detect the pattern problems. And we'll just say capitals only. And then we can have the second span which represents the min length error, so hasError min length, and watch out that this is all small letters. And then we can grab the corresponding error object for min length, and that has a required length property, so we'll use that to display the minimum number of characters. Let's have a look in the browser, and you can see that if we have less than 2 letters, we get the 2 characters. If we use a number, we get the pattern error. And then if we combine 2 problems, we see both capitals only and 2 characters. What if we wanted to create our own validation? You can see here in the country control that I've added 1 extra value, which is for Australia. And that is not part of the countries that we have in settings. So let's create a validator that will check that the selected country is within the list of countries that we get from the settings. Now just for a change, I'm not going to keep the country control on the this object. I'm just going to use this.profileform.find, and to access the country control, it's under localization country. And then on this, I'm going to set the validator is equal to a function. Now, as mentioned with the previous validators, the behavior needs to be the same. Now the function will receive a control. So the first thing we'll do is to try to find a valid country. So we look into the countries array and we match that by code compared to the current value of the control. And if we found a valid country, again as mentioned, it's the same as the other validators, we need to return null. Now if we don't find a valid country, then we will return an object, and here you can select any key that you want. I'm going to say problem, and that's not a valid country. Now I didn't keep the country control on the this object, so I can't access it directly. However, we can still use local template variables as we did before, like I have here hash cc equals to ngform, and so below the select list we can display cc dot, and we can't access get error directly because cc is the directive. But the directive has access to its control, cc.control, and that control has the getError method, and we are looking for the key problem. Let's see that in action. As long as we select one of the 3 countries from settings, everything's okay. And if we select Australia, then we see not a valid country. Next up, let's look into asynchronous validation. Now here at the top of the page, you can see that we have this new button, and if you click on it, you will see an input appears and an add button. So that's how we can create new profiles. So what if we wanted to validate that this profile doesn't exist yet? The control that corresponds to the input is this.newName control. Now since we're going to do asynchronous validation, on the new name control we're going to set .async validator, and that actually basically behaves the same as a normal validator, except that it is expected to return a promise. If everything's okay, that promise is expected to resolve with null, and otherwise with an object, exactly the same as with normal validators. So here we're going to return this.settingService.profileNames, and that's a promise. We're just going to continue with a .then. We're going to receive the list of names, and we're going to try to find c.value. C is the control. And if we do find it, we will return an object with the new name property, and a string names clash. If we don't find it, we should return null. Now because we are inside the .then of a promise, the external promise will resolve with either null or this object. Now for us to see in the browser a little bit clearer, let's delay the execution of profile names using delay and let's say 3 seconds. In the template you can see that we are going to display 3 things. Valid, which is whether the control is valid, we've seen that before, but also pending. That's quite interesting because when an asynchronous validation is happening, this will toggle between true and false. And then the error for the key new name. Let's see that in action. At this stage the form is valid and it is not pending because nothing is happening. Let's click on new, and as soon as we type a letter you can see that pending becomes true, and interestingly the valid state also becomes false. So it assumes that while something is pending it is considered invalid, and then after 3 seconds it comes back as pending false and valid true because J is not one of the existing profiles. Now let's type John. And now you can see that the moment pending will become false, valid will remain as false, and we have the error message named clash. So in this video we learned how to set validators on controls, combine them, create our own, and validate asynchronously. This concludes the section on forms. We saw how we can easily let Angular handle the building of the form by adding controls straight to the template, or decide to take a tighter control of the form model. We also handle validation and error display. In the next and final section, we will talk more about asynchronous coding, which is taking a more and more important part in today's JavaScript programming. In the previous section, we covered the use of forms and their validation. In this section, we'll talk about asynchronous programming using first promises and later observables. We'll start with promises. Although they are way less powerful than observables, a lot speaks for them as well. The simplicity of their API, their ability to be combined in various ways, and quite importantly, the fact that they are part of ES6 official features. In the second video, we'll talk about observables, which are from the RxJS library and offer their own advantages. They can very easily be laid on top of other forms of asynchronous programming, like events and promises. The library also contains a multitude of operators to map, filter, and otherwise combine observables in many ways thinkable, plus other features like being cancelable and lazy loadable. So in this first video we'll use promises. We will first chain promises to handle an asynchronous flow of actions in series, then we'll use promise.all for concurrent async processing, and finally learn how to jump from a rejected promise into a resolved or successful one. What we'll aim for here is to load the full track object before allowing it to be displayed. For that we would need to load the track itself, then the artist and the albums. Of course, each of those 3 processes are asynchronous, and that's where promises will help. Let's start with one implementation by chaining promises. Currently, we get the song using its ID, and then we set the track object on the track holder service. So how do we proceed to load the artist? All we need is to continue with a .then, and as a parameter, we'll receive the track, because this .then callback returns the track object. And that's how promises work. If we return something from within the .then callback, it will be made available in the next .then. So what we want to do next is get the artist via the search service using the artist ID found on the track. Now why does this suddenly all look red with TypeScript errors? Because we set the return type here to be a promise which resolves with a track. But right now, because of the chaining of promises, the last .then returns an artist. And so the whole process here also resolves with an artist. But even though it looks like an error right now, that's exactly where chaining is great. We can continue again with a .then, and we'll receive the artist object, which we just need to set onto the track object. And now we continue chaining. .then receive the artist from the previous method's return, and this time we load the albums of that particular artist. Again, this still shows errors because we are now resolving with an array of albums. So .then will set the albums on the artist object so that we follow the model structure. Now the last bit is that we need to complete this chain by making sure to return the track object. So let's add a last .then which returns this .track. What is great here is that you can see that the process almost looks synchronous, when it is actually in fact a series of asynchronous actions. Now let's have a look at that in the browser with the network tab of the dev console. We can see each of the get song, get artist, and load albums API call being executed one after the other. And finally, once it's all done, the track gets displayed. So this is chaining promises, which allows you to do things in series. Let's consider another implementation where we load the track first, but then we load both artist and album simultaneously. We want to wait for both these asynchronous processes to be completed before considering that the track is fully loaded. For this, we'll return promise.all, which takes an array as parameter, and in this array we just need to pass any number of promises. In our case, searchService.getArtist and searchService.loadAlbums. The promise returned by promise.all will resolve only once both promises in the array have themselves resolved. Now because promise.all returns a promise, we can use chaining again. So we can chain the .then here with another call, and what we'll receive as parameters is an array made of the resolution values of the two promises here in the same order, meaning the artist and the albums. So here what we'll do is just set the album on the artist and the artist on the track. Now the last .then is currently returning nothing, hence the TypeScript error, so let's return this .track. Now there's a known issue about the signature of promise.all in TypeScript, and so we need to type .all to either artist or array of albums, and the outcome to an array with first element artist and the second an array of album. Let's have a look in the browser, and you can now see that the song is being loaded first, but the artist and albums API calls are being run concurrently. Promise.all is a great tool to avoid race conditions and conduct asynchronous actions in parallel. Another feature of promises is to change failure to success and vice versa. You can see that I created a simple in-memory cache. When we try to get an item, it returns a promise which resolves with the item if found and rejects if not found. Let's use that in our track holder service. We'll first attempt to load the track from the cache by using get. And if the track is found, the promise resolves, so we just call .then and set the track on the service. But we also need to handle the rejection case, which happens when the key isn't in the cache yet. For that, we add a .catch, and we receive the key. Let me just log a message first. So now we are inside a .catch, we are inside a rejected promise here, but we want the global promise to resolve with the track, not to be rejected. So we need to change a failure, where we are now, into a success as we load the data from the API. Well, that's very easy with promises. As long as we return a new successful promise, the external promise also resolves, even though we return from within a .catch. So we just need to move the process we created previously into the .catch to achieve this. As it stands, the cache will never get populated, so let's set the value on the cache at the same time as we set this .track of the holder. Now just don't forget to return track here, since it is needed as a parameter in the next .then. And we can see now in the browser that the first time we load a track, the 3 API calls are made, whereas if we return to search and come back into the same track, no API call is made this time. So returning a resolved promise in a .catch results in a resolved promise, not a rejected one. This really helps to handle asynchronous process flows. The interface for ES6 promises has one extra method compared to most promises implementations, namely promise.race. The following example will use that method, but it will also show some interesting ways of using providers. Let's say you want to get data which is very important to your app, so you want to get it as fast as possible. In our case, we'll let the search try to grab its data from the iTunes API and also from the proxied API that we used previously, and we'll just pick the fastest. So first we'll need to create 2 different implementations of the search service, simply pointing to different URLs. I'll name them Direct Search Service and Proxied Search Service. Let's create those implementations by providing them to the tracklist component. We add the providers array, and we'll use the provide method with the string Direct Search Service. And here we'll use existing search service. That's a new type of providers, by the way, which uses the existing provider for search service. It just registers an alias to it. Next, we'll provide the configurable API and set that to the value Redip Solutions, which is the proxied API. Finally, we'll provide proxied search service and use class search service. Now, unlike use existing, this will create a new search service. And since we have just changed the value of the configurable API URL, it will use the proxied API. So now in the constructor, we'll inject direct search service as well as proxied search service. The inject decorator takes precedence over the TypeScript type, so we can keep search service as a type on both. Inside the search call, we're going to return promise.race, and that takes an array of promises. In our case, this.searchService.search and this.proxiedService.search. Race returns a promise which resolves as soon as either one of those two resolves. The resolve value is the same as the resolve of the fastest promise. So let me just log that one has completed in here, and let's have a look in the browser. And no matter which of the two APIs is faster, you'll always see done in either one of the two URLs, and then the log from the race being completed. And finally, the other API completes. Of course, the display of results happens as soon as one of the AJAX calls is completed. Promise.race is also very nice to handle timeouts.
So in this video, we used promises to handle an asynchronous flow and combine them in various ways. Promises are very present in Angular 2, but when it comes to asynchronous streams, Angular favors observables. Let's have a look at them in the next video. In a previous video, we used ES6 promises to control a flow of asynchronous processes. In this video, we will use observables. We will start by creating 3 observables from event streams, learn to filter the streams, and modify the outcome of the observable. Since we will make use of the search service, we'll see that observables work very well with promises as we switch from those promises to observables. So we're going to be listening to 3 things which will trigger searches. Clicking on the search button, pressing the enter key, and will also trigger a search a few milliseconds after a user stops typing. Here on the template, I've added local template variables on the input and the button. Using viewChild with the names of those variables, we have access to the input and button elements references. Once the element references are available, meaning inside AfterViewInit, let's create 2 observables that follow the relevant events of those elements. We can achieve this by using observable.fromEvent, where the first argument is the element to look at, so this.searchButton.nativeElement, and the second argument is the name of the event, click. In the same way, we can create an observable strokes, which will emit every time a keyUp event is triggered on the search input. Observables are generic, so it's always better to specify the type of what they will emit, namely mouse event for clicks and keyboard event for the strokes. So now we have 2 streams of data. Let's consider our logic. First, the clicks. We only care about left mouse click and not if any modifier key is pressed, let's say Control or Alt. So we can modify the observable by using .filter, and here we receive the event, and we'll return true for no Control, no Alt, no Shift, and the left button only. For strokes, I'm going to split them into enter strokes and letter strokes, meaning that we are just typing text. Enter strokes will be created by filtering the strokes observable and picking only events where the key code is 13. And normal letter typing is taken from strokes where no Control or Alt key is pressed, and the code is more than 32, which is the code for space. Now, if enter is pressed, we will want to execute the search immediately. But for the normal typing, we want to wait until the user stops typing. So we'll use the bounce time, 300 milliseconds, on the letter strokes observable. If you're not familiar with debounce, it means trigger only when there is at least 300 milliseconds interval between 2 strokes. So here we've seen 2 ways of altering the stream itself, filtering and debouncing. But currently, our streams are emitting either mouse event or keyboard events, which we're not really interested in when we want to conduct the search. So we'll modify what is emitted this time by using .map.
That works exactly the same as .map on an array. For every item in the stream, we replace the value with what we will return here. And what we care about is the value of the search input, so let's return that. Now at this stage, we lose the typing of observable because .value is typed as any. So let's tell TypeScript that this will be a string, and now clickString is an observable that emits strings. Let me do the same for enter strokes as well as letter stroke, and now we will have 3 streams that emit the current value of the input at the times we want it, on click, on enter, and after the user stops typing. Of course, what we want is just one stream. Any one of those triggers should just trigger the search. So we'll let search requests equal to observable.merge and pass the 3 existing observables to merge them into a single one. Conveniently, since all 3 sources emitted strings, this new observable is also typed with strings. Now, before we trigger the search, there's a possibility that after we are done typing, we then press the enter key. And so this observable would currently emit twice the same value. We can take care of that by adding .distinct until changed, and so consecutive values will only be emitted if they are different. We're finally ready to execute a search each time this observable emits. So let search results equal to search request dot switch map, we receive the term, and let's console.log that term and return search service.search with the term as argument. Now why are we using switch map? Why can't we use map? If you used map here, what you'd emit each time is the promise returned by search service.search. But that's not what we want. We want to emit the results. Now, a promise is very much like an observable that only emits one value and then completes. Switch map takes such observables and re-emits their values. Actually, it does one more thing as well, which is perfect for us. It stops caring about an observable as soon as a new one has been emitted on its source. So in this marbles diagram, for example, as the search results for hello are emitted, switch map will emit them as well. Now let's say we start a search for MA, but before the search completes through the API call, another search is requested for the term massive this time. The behavior of switch map is to then not emit the results for MA, since another stream has already started. That's perfect because it guarantees that we will never have the results of an older search overlap those of the latest search. By the way, to see that effect later in the browser, I've added a 5 seconds delay on the search service API call. Now all that remains is to subscribe to that final observable and we'll receive the results as an array of tracks, and we can simply log the length of the results and then emit them on the complete event emitter, which is then passed on to the track list component and rendered. Let's have a look at all this in the browser. Let's type in the input and you can see the search term only after I stop typing. And then 5 seconds later, the API call is made and we get our tracks. Pressing enter right now doesn't trigger anything thanks to the distinct until changed modifier. But if I quickly change and press enter, the search doesn't wait for 300 milliseconds, it is triggered immediately. Also notice how backspaces are being ignored. Now let me refresh to get a clean slate, and I'll start a search for mass, and you see the term being logged. But before that completes, I'll finish typing massive and then press enter. So you can see the second search term log, and now after a few seconds you'll see 2 done logs because both API calls have been executed. However, you'll only see one single log for the number of results, and the tracks are only rendered for the latest search. All that thanks to switch map. It's important to remove subscriptions to observables when we are done, so let's implement onDestroy. And we'll save the subscription as this.subscription. Then just add the ngOnDestroy method and call this.subscription.unsubscribe. Doing this helps you prevent memory leaks. In this video, we introduced a few of the many operators of the RxJS library to filter, combine, and map observables. This concludes the section as well as the course. I hope you enjoyed learning about Angular 2 and that you will have fun coding with what promises to be a very exciting framework. As always, feel free to clone this repo, contact me with questions by creating issues there, and expect to see updated code on new branches when major releases of Angular 2 come out. Thank you for listening, and I hope to see you soon on another course.